Khadija or Mashal, why do we need units and what is basically SI unit system? What is the SI system and why do we need units? Anyone can participate over here. Yes, Mashal. What are units and why do we need SI system?
So basically, SI unit is a standard international system of metric unit which is used to identify which type of unit we are using. For example, अगर I'm saying that I have ran 10, so what 10 is it meters, kilometers or what? So इसलिए हम जो है वो साथ इसके यूनिट्स भी लगाते हैं मीटर्स, कि मैं 10 मीटर्स रन कर चुकी हूँ. तो अगर हम ये नहीं लगाएंगे तो हमें पता नहीं चलेगा कि what we are talking about.
Okay, that's good. That's good, right? So we have discussed what is SS system over here. SS stands for Systematic International Unit System over here. So why do we need this? We want to standardize everything. Okay, we want the lengths to be shown in meters. We want the masses to be shown in kilograms, okay, and so on and so forth. And we discussed that we have 7 base quantities. We have length, mass, time, temperature, amount of substance, intensity, current, right? These are 7 base quantities, and if we combine them in different combinations, we get other quantities like power, acceleration, force, right? Momentum, right? We get movement, okay? We get so on and so forth, which are called basically derived quantities, right? Because we derive them by a combination of these base quantities, okay? And their units are called basically derived units, right? We also talked about some prefixes in the last class that we have some power in the negative that are called basically from deci, centi, milli, micro, nano. So you should remember these basically prefixes over here. If you're doing calculations, you always want to remove this prefix, right? If I can draw or highlight, you will have, let's say the length of the track is 2 kilometers, right? So this kilo needs to be removed before doing the calculations because kilo stands for what? It stands for 1,000, right? So we also have powers in the positive. Okay, we have kilo, mega, giga, tera. Okay, and these are the prefixes representation over here, and these are the standard forms in 10 to the power, right? So this answer is called in standard form. Okay, so we preferred standard form to basically to minimize to basically write the answer concisely so that we have a very consistent form of writing the answer, right? Instead of writing 0.000 or let's say 0.00001, we can write let's say 1 micro, right? So that basically concise your answers. Okay, so we have powers of 10 जो हमने discuss कर लिए बैठ के. So this notation is called standard notation, right? And we have length. We have discussed length. What is length, by the way? Length is basically, let's imagine this is Hamza over here. Hamza is walking on a track, right? उसने 2 point mark करे में point A, point B on the track. And basically length क्या है? Length is basically a distance between these two points over here. So it is usually measured in meters. And which instrument can we use to measure the length? We can use a tape meter rule, right? We can use a half meter rule. Let's say our length is less than half meter. We can use a half whole meter rule, right? And so on and so forth. Then we have some errors when we are basically measuring the length, right? So whenever you're doing some experiments, let's say आपका 80 पे question आता है बैठ के and your question involves measuring lengths. They can ask you, okay, what can be the source of uncertainty in the question? Right? So with closing your eyes, you will directly see it's a parallax error, right? So what is parallax error? Can anyone tell me what is parallax error, Khadija?
It is a human error which occurs when your eye is not directly on the point and you overestimate the quantity.
Yeah. So you want to basically place your eye perpendicularly to the reading. If your eye is at a particular angle from the reading, right, you can have some deviations, right? You can either overestimate or underestimate the answer, which will basically introduce some uncertainties in your answer and basically inaccuracies in your answer, right? So then we have powers in the negative, which we have discussed already, right? We have discussed kilo क्या होता है, giga क्या होता है बैठ के. So this is just a revision over here. Significant figures, right? This is pretty important discussion over here. Let me just first of all skim the content, and then we can have a discussion on this. Okay, what is meant by significant figures, right? Scientists try to make sure a measurement is accurate, right? Close to its true value, which we all do, right? However, the apparatus and experimental procedure may have some sources of error. Like let's say if you're measuring lengths, right? The measuring lengths over here, let's say. and let's say this is the actual rod which you want to basically measure the length of this rod, and let's say you're looking at the length from here, right? See I, you might basically read this value, right? And this is at a particular theta angle over here, and this will introduce what? Parallel axis, right? So your reading will not be perfect. It will basically be containing some errors over it, right? So the number of digits called significant figures given for a measurement indicates how accurate we think it is, right? So the least count क्या होती है हमारे पास? If you see your scale, right? If you see your meter scale, you might observe कि आपकी जो smallest reading हो सकती है, which can measure by your scale, is basically what? 0.1 centimeter. So the smallest division in your scale is basically what? 0.1 centimeter. So the least count of this instrument is half, or basically half meter rule is 0.1 centimeter. So iski accuracy is basically 0.1 centimeter, right? So if you keep on increasing this accuracy, let's say if you have an instrument which can measure lengths up to 0.01 centimeter, so it is more accurate, right? It is more accurate than this reading over here, right? So this is basically called the precision, the accuracy of instrument over here. You should not give more digits in a calculated answer over here than that are unjustified, right? Let's say आपका smallest count scale की 0.1 centimeter, and you're making measurements. Let's say आपने यहाँ पे measurement ली बैठ के at this particular stage, and you say कि मेरी reading आ रही है, let's say 4.505 centimeter. It is not possible, right? It is your mental game कि आप कह रहे हैं कि roughly around closely to this value would be the answer, but your scale can measure up to the smallest reading is that is 0.1, right? Cannot measure up to 3 decimal places, right? So this is also incorrect. You should always know okay, what is your least count of instrument, and depending upon that, you're gonna basically be doing measurements, right? So when doing a calculation, your answer should have the same number of significant figures as measurements used in the calculation, right? For example, if your calculator gave an answer 3.41850062, that is basically pi. This would be written as 3.4 if the measurements had two significant figures, right? Let's say if your measurement is using a half, let's say a meter rule, okay? Let's say it's a meter rule over here. It's इसकी जो accuracy होती है, right? The accuracy of the scale is basically 0.1 centimeter, right? So it can measure up to one decimal place in centimeters. So your answer should be in basically one decimal place. Okay, that is two significant figures over here. It cannot be 3.42 because that is not the accuracy of the instrument, right? You cannot give that much accuracy, right? And if you are adding your answer as 3.42, how can you prove your scale can measure up to that? If your scale accuracy is 0.01 centimeter, that you're sure कि इसकी least count, इसकी जो minimum count है, the minimum basically it can count is 0. Up to 2 decimal places, then you can go up to 3 SF over here, right? Your answer can be basically 3.4. Does that make sense or not? Yes or no? Or it is confusing? Khadija, Shal, Hamza, it makes sense? Yes or no?
जी
Give me a thumbs up if it makes sense. Or just say yes.
यस
Hamza, समझ आया आपको? अस्सलाम वालेकुम। अस्सलाम वालेकुम। यार नहीं ज्वाइन नहीं किया। Sure, sure, sure. I would allow him. Yeah. Okay. Sure. Okay. ठीक है, so it's basically discussion upon your instrument, right? So physics में you cannot just go blindly कि आपका आंसर let's say आपने measurement ली and आपको लग रहा है कि 3.456 होगा, ठीक है? So you cannot be sure until and unless your instrument is accurate, ठीक है? If you're sure कि आपके instrument की accuracy इतनी है, then you can basically write the answer in that number of decimal places. Otherwise, stick to your instrument accuracy, right? Okay. So now let's move on. Okay, so we have some discussion on areas over here, right? So it's pretty simple, just basically discussing on how to go from centimeter square to meter square, from centimeter cube to meter cube, right? So they have used the book have used the analogy of areas over here, right? So what is the area of a? Let me insert a slide. Okay, it makes sense. Let me now new slide, blank slide. Okay, so let's imagine we have a square over here. Its length L centimeter by L centimeter. How to compute the area? The area is simply what? The area is length into length. That is L square, right? L square. If I talk about area of a triangle, how do you get a triangle? You can either have this shape, that is the height over here, and this is the base. Or you can have this shape, right? Directly a right angle triangle. This is the base, this is the height. How to compute the area of this triangle? It's basically half into base into height, right? If I give you a circle, okay, so it's basically what? It's just has a center, okay, it has a radius. And how to compute the area of a circle? It's pi r square, right? So they are basically using this analogy to tell you how to basically convert from centimeter square to meter square. ठीक है? तो इन लोगों ने क्या करा है? इन लोगों ने बोला है कि let's imagine you have a square, ठीक है? You have a square of 1 centimeter by 1 centimeter, right? So what would be the area of this square? The area would be simply 1 centimeter by 1 centimeter. That is going to be what? 1 centimeter square, right? And they're simply stating that if you have, let's say, a rectangle of 4 centimeter by 3 centimeter, so you basically combine 12 squares of 1 centimeter by 1 centimeter to form this particular shape, right? And they say that you just basically multiply area of a one small 1 centimeter by 1 centimeter square times 12, right? Or it's just 3 into 4, right? इसका area क्या होगा rectangle का? It's 3 into 4, right? That is 12 centimeters square. Up, how do you convert from centimeter square to meter square? That's the question over here, right? So how do you convert from centimeter square to meter square? इसको देख लेते हैं बैठ के हम लोग. You want to go from centimeter square to meter square. ठीक है? Can anyone tell me कि let's say if I have a reading, let's say मेरे पास area आया 12 centimeter square, right? Of the bigger, let's say we have a rectangle over here, which is of 4 centimeter by 3 centimeter, right? इसका area is basically 12 centimeter square. They want to convert this area into meter square. There you have two options, right? You can either convert the length and breadth into meters and then find the area, or can do it directly, right? So let's do both of them, right? Let's do the first method. You can convert the length and breadth to meters, right? So let's do that. So what's the equivalent of centi? What's the equivalent of centi? Mashal? What is the equivalent of centi in 10 to the power something? Yes, Mashal. Is it 10 to the power minus 2 or is it 10 to the power minus 1?
10 power minus 2. 10 power minus 2.
10 to the power minus 2, right? So whenever you have centi, so you want to remove the prefix of centi by the equivalent power, right? We have discussed the powers. We have the following powers over here which are available, right? So basically centi stands for 10 to the power minus 2, right? You can remove this centimeter by the following. This centi is our put its equivalent power. So the length is basically 4 into 10 to the power minus 2 meters, right? And the breadth is 3 into 10 to the power minus 2 meters. You can find the equivalent area by just doing length into breadth. That is going to be the following. It is 4 exponent minus 2 into 3 exponent minus 2. Right? And your area comes out to be what? Something in meters square. So always keep your pencil, calculator, and copy with you, right? So it's 4 exponent minus 2 times 3 exponent minus 2. This is going to give you 1.2 milli, right? 1 point, let me just do it, 1.2 10 to the power minus 3 meters square, right? This is method 1. Okay, you can convert the answer to meter square using this. So what is the method 2, which is going to be focused upon mostly, and it has been focused in your book, that is converting centimeter square directly to meter square, right? How can we do it? You can do it as following over here, right? So what is 1 meter equivalent to in centimeters? It is basically 100 centimeter, right? Right, if you recall this, okay, 1 meter is 100 centimeter, right? So how
Yes.
do you convert, basically, how do you get the squares? You square on both sides, right? The square on both sides. So you get 1 meter square, 1 ka square is 1, meter ka square is meter square, is basically equivalent to, what is 100 ka square? You can just use a calculator if you want. It's 10,000, right? It's 10,000 centimeters square. Okay. So now we're gonna apply some ratio method over here. Okay. We're gonna apply ratio method over here. And what is this method? You just have a direct relation from meter square to centimeter square. So you can just use this ratio method. 1 meter square is 10,000 centimeter square. अब जो आपका आंसर है, that is basically what? The answer is 12 centimeter square, right? So just below the centimeter square, I'm gonna put the value of centimeter square, जो आपका answer actually आया, that is 12 centimeter square, right? You want to convert this into meter square, that is x unknown, right? And you have a famous trick of this, that is called shake shake. Okay, I call it what? Shake shake. Simply do what? Simply do shake shake. So gonna cross multiply, right? So it's going to be basically 1 times 12 equals to x times 10,000. So if you make x subject, that is the 10,000 going to basically go over there and divide, right? So your x is going to be basically 12 upon 10,000. That is again, therefore your answer is 1.2 exponent minus 3 meter square. Okay, so that's how you convert from basically centimeter square to meter square. Does that make sense? Yes or no? We have Abdullah
Yes.
also over here. Does that make sense? Abdullah?
Sir, do you hear me?
Does that make sense? Okay, I guess if you guys are quiet, I think it makes sense, right? So there are either two options. कुछ समझ नहीं आ रहा है, सब समझ आ रहा है. Okay? If it makes sense, give me a thumbs up, all of you. Quickly give me a thumbs up. Okay, it makes sense to Mashal. It makes sense to Hamza. What about Khatija? No. Yes. Abdullah. Okay, Khatija ko it also makes sense. Abdullah, does it make sense? Okay, how do we convert from centimeter square to meter square? It's going to come in handy in future, right? Yeah. Okay, so it makes sense to all of you. That's good. You all are smart kids. So now, since it makes sense to all of you, I want you guys to find out the answer of this triangle in meter square. Okay, you guys have 3 minutes to solve the question. It's pretty simple. So you have two triangles over here. So A and B. So you can just do part A. This is your homework, right? This is your homework. You can do it before the next class. You can just do part A. Give me the answer for this triangle in meter square. You can drop in the answer in the chat, or you can just directly tell me the answers to your minds. So yeah, so we have discussed something about physics. Okay, what is physics in the first lecture? If you haven't watched the first lecture, it was pretty interesting. You can watch the recordings in the recording folder. Abdullah, I have told them that you have a record. You're gonna get the recording of the lecture as soon as the class is over, right? Within 1 hour, it converts and then it is going to upload into the portal. And then you also have your TA, okay, teacher assistant. So I have hired him especially for you guys. If you have any questions, any queries in your homeworks, you can post them on the WhatsApp group. So within 24 hours, Okay, I'm gonna get some answers from the TA. If you want specifically me to answer the questions, you can tag me on that query, right? Always send a query as a PDF, not just send pictures, right? So PDF basically makes more sense to me, right, than pictures. I just want one answer to just continue, right? This is a verb with a and we are doing hot. We are using hotter के book, ठीक है? So it's the official Cambridge book. If you guys don't know who missed the lecture, PDF मैंने WhatsApp group पे भेजा हुआ है. If you haven't received it, I'm gonna share it again to you guys privately. जो नए बच्चे आ रहे हैं. I want the answer from Abdullah. I want to see is Abdullah working on it. You have then volume already. ठीक है.
Sir, I have the answer.
Okay, Hamza has the answer. Okay, Hamza, what's your answer?
1.2 multiplied by 10 to the power minus 3.
Okay, so Hamza has the answer. That is 1.2 10 to the power minus 3 meter square. Right? Okay, ठीक है. So I guess everyone is done. So let me continue and we can check out if Hamza's answer was correct. So we know the formula for the area of triangle. I just wrote it down in the last slide. That is half into base into height, right? So you can just basically find out that this is the base over here, this is the height over here, right? So it's going to be, area is going to be basically half into 4 into 6, right? So 2 ones are, 2 twos are, so your area comes out to be 12 centimeters square. You convert this into meter square directly from this ratio method, that 1 meter square is 10,000 centimeters square, and you have the answer, it is 12 centimeters square. That is going to be x meter square, right? A meter square on work, sorry. So it's going to be cross multiplication over here. So your x is going to be basically 12 upon 10,000. And that is correct. That is going to be 1.2 exponent minus 3 meters square. Okay, write down the answer as following also. That is 1.2 millimeters. Okay, because milli क्या होता है? Milli is equivalent to 10 to the power minus. So you can replace the power by prefix also. If you want to be sure, let's say if you're given in the question, can use prefix in your answers. You can also use prefixes, right? Or you can leave the answer like this also. I'm gonna give you full marks, right? So after every 2-3 chapters, gonna have a test that you guys are all prepared. कि क्या चल रहा है class के अंदर. I know कि you guys don't study without test. So we also prepared for surprise quizzes also in the lecture. Okay, I might take surprise quizzes also, right? So when you are joining the class, so you should be aware of the content of the last lecture. फिर मैं last class में क्या पढ़ा था. ठीक है, then we have volume over here, right? So let me just share ये how do we go from area to volume, right? So if you just recall जो basic mathematics, so you have 2 dimension, right? आपके पास let's say you have a rectangle, इसकी length होती है, इसकी breadth होती है, right? This is a rectangle over here, right? Length and the breadth. If I have some power, let's say मैंने उस rectangle को मैंने थोड़ा बाहर निकाल, right? Let's say if I have some power, I can make things live. So let's say if I took my hand, if I picked the rectangle and basically I took it out. So it also has some basically height, right? So it has a 3-dimensional shape that becomes a cuboid, right? It becomes a cuboid like this. So now it has length, it has breadth, it has height, right? So whenever you have a 3-dimensional surface, right? What is a 3D surface? It has 3 sides, length, breadth, and height, right? So up इसकी हो जाती है volume, right? Because it is occupying some space in your area. Let's say if you have a calculator like this, okay, imagine कि it's a cuboid, right? It has length, it has height, it has width, right? So it is a 3D thing over here. You can see all of its dimensions, right? So it is going to occupy some space, and that can be found out by using a volume, right? So how do you find a volume of a cuboid? That is its length times breadth times height. Make sense, right? इसके हम निकालते हैं वॉल्यूम. क्या है ये वॉल्यूम? दैट इज गोइंग टू बी लेंथ टाइम ब्रेथ टाइम हाइट. ठीक है, इसकी लेंथ, लेट्स से इसकी लेंथ ये है, इसकी हाइट ये है, इसकी ब्रेथ ये है. तो गोइंग टू बी बेसिकली सिंपली 4 times 3 times 5, राइट? ठीक है, तो 4 centimeter times 3 centimeter times 5 centimeter. Going to get the following answer, that is going to be 4 into 3 into 5.
Sir,
That
60.
60. Yeah, 60 centimeter cube. Up, if I have a question for you guys, okay, how do we go from centimeter cube to meter cube? Now we have a new question. Now we want to go from centimeter cube to meter cube. That is pretty simple again. We have the relation from meter to centimeter, right? Okay, 1 meter क्या होता है हमारे पास? It's 100 centimeter. If you just cube on both the sides, right? You cube both the sides, you're gonna get what is 1 ka cube? It's 1, right? 1 meter cube. And what is 100 a cube over here? That is going to be 1 million, right? 6 zeros. Centimeter. Right? So you have this relation over here. You can again apply ratio method, or you can do what? You convert all the individual lengths to meters and then multiply. Right? You have two options, whatever suits you. So in the direct conversion, this is pretty useful. It saves time and it saves also your space of working, right? So you have your answer, that was 60, right? You can apply directly your ratio method, that 1 meter cube is equivalent to what? 1 million centimeter cube. You have how much volume in your hand? That is 60 centimeter cube. You want to find its equivalent volume in meter cube. Just simply cross multiply. When you get what? X times 1 million equals to 60. Right? And how do you make x subject? ये यहाँ पे multiply हो रहा है, वहाँ पे divide हो रहा है. So x is going to be basically 60 upon million. Right? And your answer in meter cube is going to be the following. Something in meter cube. So if you do 60 divided by million, so it's going to be 6 to the power 10 to the power minus 5 meter cube. And you should know how to convert it into its standard forms. If you don't know, you'll be stuck in your exams, right? So this is the basic building chapter over here, and I hope it makes sense, right? Achha. So let's move on. If you have any questions, stop me over there. Right? Khadija, you had a question? You were speaking in between.
No, sir.
Okay, ठीक है. So volume हमने कर ली है बैठ के, right? So now if I say कि if I want to find a volume of liquid, how can I find the volume of liquid? Can anyone tell me, कि let's say if I have this apparatus with me, I have this apparatus over here, right? How can I find the volume?
By looking at the measuring cylinder.
Yeah, by looking at the height and then doing what? Yeah, okay. So that is correct. You have a measuring cylinder over here, so it's an instrument that you can find in your labs. Okay, just go to your lab, grab one, and find the volume of liquid. Just pour some tap water into it, and then find the liquid volume. Okay, so it's called measuring cylinder. Okay. So what do? You have some volume over here, right? So you have let's say if you pour some water down the cylinder over here, and you're gonna have some meniscus, right? What is the meniscus? So if you pour some water, your water is going to basically either it's going to have this shape, right? Okay. So this basically thing which is basically sort of tilted, it's called the meniscus, right? It's called a lower meniscus. This is called a meniscus. So you want to basically look at this level, right? Perpendicularly. So you want to keep your eye in such a way that your meniscus, the lower meniscus, is basically in line with your eye, right? It's making angle perpendicular angle with the surface. There you can see the actual answer, right? Let's say if your eye is over here, if it is over here, you're gonna see something else, right? You're gonna see something like sort of this. You're gonna overestimate the answer. You want to always keep your eye perpendicular so that you don't basically you avoid parallax error. wherever you have something involved in taking readings from your eyes, you want to make it sure it's perpendicular, right? Let me just write down the spelling correctly. It's making weird connections with each other, right? You want to avoid parallax error over here. So you can just directly take the reading, and yes, always mention over there, is it reading, is the reading is going to be in centimeter cube, or let's say milliliters में होगा हमारे पास. So you can then convert into meter cube if you know how the conversion, right? So that's how you find the volume of a liquid. So it's part of a ATP, that is alternative to practicals, right? The volume of a liquid may be obtained by pouring it into a measuring cylinder. Okay. When making a readings, the eye must be kept upright to avoid parallax error. Okay. And you want to see the meniscus, right? Okay, to keep to basically measure the reading. Don't just directly see over here, right? If you see at this particular point, you're going to get a different reading, right? So meniscus give you the average approximate reading कि आपकी volume liquid कितनी है, right? Okay. So now we have some conversions which you should basically know. Chemistry में आप लोग पढ़ा होगा बैठ के कि 1 decimeter cube is 1 decimeter cube is equivalent to 1000 centimeter cube, right? And this is equivalent to 1 liter, right? So this is some relation which you should know in basic measuring cylinders. And I guess इसके अलावा there is nothing much to learn from over here. So now let's talk about some cylinders, right? So what are some cylinder? What is a cylinder? You have some sort of this shape over here. ठीक है. उसका आपके पास we have this the top and the base circular, right? It's the radius over and it's the height, right? And you know in your from your basic mathematics, if you want to find the volume of a cylinder, that is basically pi r square h, right? Let's say अगर मैं आपको सिर्फ हाइट दे दूं वाटर की, and you know कि सिलेंडर का रेडियस कितना हुआ है हमारे पास जो इंस्ट्रूमेंट आप यूज कर रहे हैं. Let's say the readings on the cylinder are basically rubbed out. It's pretty old. You want to find out the volume using some mathematical tools, right? So you have the height, you have the radius of the circular basically top and the bottom. So you want to find out the volume of the liquid in that particular condition. Okay. So आपके पास radius is 10 millimeter. So what is given to you? We have the radius in 10 millimeters. We have the height in basically 5 centimeter. We want to find out the volume, and you know the formula for volume, that is pi r square h. First of all, you can do what? You convert, you remove the prefixes over here, you remove milli, you remove centi, okay? And then just put into the formula and get your answer. Okay? So give me the answer. What is the radius in basically meters? Milli क्या होता है? Milli is basically 10 to the power minus 3, and centi is 10 to the power minus 2. So you have everything over here. I just want the value of the answer. Should be in meter cube. Abdullah, are you working? Or are you chilling out? Abdullah, are you here? I guess he's chilling out. Just give me the answer, any one of you. Till listen. I want to move on. So meeting is about to end. Kindly e-join. Okay? Everyone e-join with the same link. Okay, guys, done? Is anyone done? Chale. Is anyone done?
Yes.
Okay. Answer क्या आ रहा है हमका?
15.7 multiplied by 10 to the power minus 5.
15.7 multiplied by 10 power minus 5. Okay, Hamza is pretty fast. Okay. Where are the other girls and boys? Abdullah, I want everyone to participate. Now I'm gonna call you in the next question. Okay? So keep your copy and a pencil and your calculator with you. Okay? अच्छा जी. So let's check it out. It's pretty simple, right? You just have to substitute the values over here, right? It's going to be pi into radius what? 10 to the power 10 multiplied by 10 to the power minus 3. Because milli की equivalent क्या होती है? It's 10 to the power minus 3 square times the height of the basically cylinder, that is 5 centimeters. So centi अगर आप remove करेंगे, you're gonna put its power, that is 10 to the power minus 2. ठीक है? Just use your calculator, get your answer. That's it. Okay, so pi into 10 to the power minus 2 minus 3 squared times 5x squared minus 2. So it's coming out to be basically 1.57. And I say again, coming out to be 1.57 x squared minus 5. I think, Hamza, you meant 1.57? It's
No,
1.57.
let me check.
It's 1.57. Okay. अच्छा जी. So let's move on. ठीक है, discussion on time. ठीक है, time is pretty important, right? सर हमेशा ये कर देते हैं. तो बिकॉज मेरे पास इशू हो रहा होता है बैठ के, बेसिकली मेरे पास बफर आ जाता है, राइट? सो लेट से आपसे पहले मेरी क्लास है, तो वहाँ पे डिस्कशन में थोड़ा टाइम लग जाता है बैठ के, तो वो लेट हो जाता है. ठीक है, सो टाइम इज वेरी इंपॉर्टेंट. ठीक है, केयर अबाउट इट. अच्छा जी. सो ये मेरे हैंडल से क्या हो गया भाई? लेट मी फिक्स. सो व्हाट इज टाइम? कैन यू टेल मी टाइम क्या है भाई? व्हाट इज टाइम एंड हाउ डू यू मेजर इट? What is time? Don't just read the stuff and tell me that. So basically, time is basically measured in seconds, right? So it's the interval of time. So let me just, time is, it's basically the interval of measuring the elapsed duration, right? So hota kya hai? Let's imagine if I can take you guys to the point where the universe was born. Okay, let's go back further generations away. So let's imagine you were this was basically the point of Big Bang, right? So what is Big Bang? Big Bang is the point where basically everything was found, right? Poof, a blast and everything came into being. Okay, so everything basically exploded and it is basically accelerating in this direction, right? Every universe, every galaxy, okay, every planet, every star basically is basically incrementing, right? So यहाँ पे time was zero, right? So now as the universe expanded, the time began. Okay. So if you guys want to basically have an interesting fact, time is a dimension in space. What do I mean by that? Okay, if you want to locate a star, if you want to locate a galaxy, let's say this is the sun and this is Mother Earth. Okay, and this is Mother Earth over here. If you want to, let's say, locate, let's say, some any other planet, let's say if you want to locate Saturn, right? So you would have to basically also fix a point of time. Okay, because when you're looking at, let's say if you're looking through a telescope, अभी अपने छत पे बैठ के you're looking at the moon, so you're looking some seconds into the past, right? Because time is also moving in space. As you go to the right, time is also basically changing. सही है. So just to keep it on simple terms, time is basically a unit which is invented by us for the earth, so it's measured in seconds, right? So यहाँ पे time has a different definition in space. Okay, so just to keep it simple, time is basically measured in seconds and we use clocks, watches, okay, and pendulum clocks to measure time. Okay, so days, how do we basically measure days? Okay, let's say we cannot measure time in days because there is not the standard system in the entire world of us. Okay, so we have a fixed definition, the SI unit of time, that is seconds. So we know कि 365 days कितने होते हैं हमारे पास? We know कि there are 24 hours in one day, and in 1 hour we know कि there are 60 minutes, and we know कि in 1 minute we have 60 seconds, right? So to convert the days into seconds, we want to multiply it by 24 first, and then multiply by 60, and then multiply by 60 over here, convert the entire duration of days into seconds, right? So we want to keep everything to be standard. That is why we have the SI based unit system for every, we have 7 base units. Okay, uske we have 7 base units, and we want to keep things standardized. Okay, that is why we don't measure time in days. Okay, we measure in seconds. Okay, and what we can do, we can basically use stopwatch, clocks, pendulum clocks. Okay, standard stopwatches basically measure time. ठीक है, so if you want to keep it simple, let's say मैं अभी आपको पढ़ा रहा हूँ बैठ के, 1 घंटे बाद आप सब let's say you're watching a movie, right? So I am teaching you guys, that is event A. ठीक है, let me just insert a blank slide. Event A क्या है मेरे पास? सर खुजैमा teaching some boring stuff. Okay, ठीक है, and then we have event B, that is you guys are watching movie, right? It's a Sunday, obviously you're gonna watch a movie. ठीक है, so we have two events. The duration between these two events is called time, right? Let's say after let's say 1 hour, going to go from event A to event B. Okay, so that is basically time. Second, I have something very interesting stories, but I don't want to share at the moment because you guys will be confused. कि सर क्या बोल रहे हैं, टाइम ट्रेवल आ गया, ये आ गया, वो आ गया. ठीक है, just to keep it simple, if you have event A, if you have event B, the duration between these two events is called time. And how do we measure time? The SI unit of time is basically seconds. ठीक है, and how do we measure it? How to measure it? Yes, Khadija, how do we measure time?
We measure time by using clocks, pendulums, and stopwatches.
Yes, perfect. Okay. So we use basically stopwatches, pendulum clocks, or quartz crystal clocks. Okay. Or just keep it a stopwatch, right? Measure time over here. सही है. So a stopwatch has an accuracy of basically precision of 1 second or 0.1 second. ठीक है. So if you basically are measuring time using a stopwatch, there might be some errors also. ठीक है. So whenever you're measuring something, हर quantity के अंदर we have uncertainty, वो errors होता है हमारे पास. ठीक है. Let's say if you're measuring some lengths, you have parallax error. ठीक है. If you're measuring some time, you would have human reaction time. ठीक है. And what is human reaction time? These are all the terms which can pop in your practical exams. ठीक है. So make notes. I would say कि make notes while I'm giving lecture, right? So let's say if you have experiment, this is your race over here. This is the finish line, right? This is the finish line over here. And let's say Abdullah is running a marathon, right? This is Abdullah over here. And Abdullah basically finishes. And let's say there's a person standing over here who is basically having a stopwatch, right? This is the stopwatch over here. Imagine this is not an Apple stopwatch, okay? I was a student of Picasso, right? He taught me pretty great drawings, okay? So stopwatch basically when it starts and stops the stopwatch ना, तो हमारे brain क्या करता है? हमारा brain basically sends the signal to the hand कि start कर the stopwatch. Okay, so this duration from ordering the hand to start the stopwatch till it reaches and does the thing, it takes some time. Okay, because we have a human brain and it takes some time to process and do the stuff. That is called human reaction time. Okay, so we have one source of error in this. That is called what? Human reaction time. Okay, it can vary from what? It can vary from 0.1 second to 0.3 seconds. If you are younger, okay, so it is pretty small for younger people. If you have pretty old people in the marathons, okay, they are gonna take more time to basically start the stopwatch and stop, okay, and stop the stopwatch, okay. So yeah, I'm not making fun of them. I respect the elders, okay. Don't take me wrong. Okay. So it depends upon the age. Obviously, as you age, your mind basically your processing slows down, and it is just a scientific value. मैंने कुछ काम मुझे बताया नहीं. So yeah, respect everyone. Don't just say कि सर मजाक करते हैं. So yeah, so we have one experiment which is used to measure time periods. So ये आपने देखा होगा labs के अंदर. So इसके अंदर this basically comes in your exams. Let's say you have a pendulum setup. How do you measure times? Okay, the time period for one oscillation. Okay. So can anyone tell me? Does anyone have an idea? कैसे करते हैं? How do we measure time period using a pendulum? Anyone? Give me a guess. You have the apparatus over here. आपके पास retort stand है. आपके पास एक clamp लगा हुआ है. ठीक है. So you have this retort stand. You have the clamp over here. जो उसको basically support कर रहा है and it's keeping thread together. You have a string over here. You have a metal pendulum bob. ठीक है. And it's basically passing between point A and point B. Can anyone tell me कि how do we measure time period for one oscillation pendulum? Give me a guess. Can be correct or wrong. I am not going to judge you.
Sir,
Yes.
the pendulum bob goes from point A to point B while we have the stopwatch and we start and stop it.
Mhm.
We do it like 3 to 4 times and we divide the time taken and yeah,
Good.
and the times we did it.
Good. Good. Perfect. ठीक है. मुश्किल नहीं आसान है. ठीक है. Speak up in the class. ठीक है. That is pretty good. I might give bonus marks for the people who are speaking in the class, which might appear in your tests. ठीक है. So up that as Khadija said, okay, let's imagine we have a pendulum, right? We have let's say a pendulum. Let me just imagine कि ये fixed support है हमारे पास. And this is the pendulum over here, and the pendulum goes from point A to point B. Right? This is point A, and it goes from here till this particular point B. Right? So it basically, let's say, as it swings, okay, it's going to come to point B and point A and then B, right? We're going to have this sort of oscillation start. Okay. So let's say we are starting from point B. हमने अपना point B को बनाया reference. This is our reference over here. Okay. So what is the algorithm over here? As soon as it basically leaves B, we're gonna start the stopwatch, right? Start the stopwatch as it leaves point B, right? And as soon as it comes back, this is one oscillation, right? So we're gonna keep counting at least 10 oscillation, right? So count a period for 10 oscillations. What is the oscillation? It's just a to and fro movement, right? B से A पे गई, A पे वापस B पे आ गई, one oscillation, right? So we're going to keep on counting. Say B से A, then B, one count. Keep it rotating. B to A, then B, two oscillations, then so on and so forth. Till it completes 10 oscillations, right? And then we'll do what? And take average for one oscillation. ठीक है. तो आप क्या करेंगे बैठ के? You can make a table. You can make a table over here, right? That is basically the experiment number, S number. You can just take let's say 3 readings. ठीक है. This is the period for 10 oscillation. ठीक है. Period for 10 oscillation, and this is the average period for one oscillation. Let's say ये आपने पहले दफा experiment किया and you took 10 readings for the oscillations. It came out to be let's say 32 seconds, 32.47 seconds. Then it came out to be 31.42 seconds. It came out to be 30.5 seconds. Right? Then if you do divide by 10, it's going to be 3.247. It's going to be 3.142. It's going to be 3.050 seconds. Right? Now you have these 3 readings over here with you for one oscillation. Now you can take another average. Okay. So how would you find the final average? The final reading, let's say FR. So your FR is going to be basically what? 3.247 plus 3.142 plus 3.05 divided by 3. To be more precise, right? We are removing basically increasing accuracy by taking averages. So the final rating is going to be the following. It is 3.247 plus 3.142 plus 3.05 divided by 3. So it's coming out to be 3.15. ठीक है. And we are basically assuming कि हमारे stopwatch की accuracy is 0.01 seconds. right? This is the least count of our stoppers. That is why we are leaving the answer in 2 decimal places, right? अब आप किससे क्या आ गई है? The time period for basically one oscillation. We also find the frequency, right? And what is frequency? Let me tell you that. So you know what is the time period for one wave, for one oscillations on average. आपने बहुत सारे average लिए हैं, तो you have very precise accurate answer. ठीक है? That is 3.15 seconds. ठीक है? So now if you want to find the frequency, what is frequency? Anyone tell me what is frequency?
Number of times.
Yeah. So number of times your basically your pendulum oscillates in 1 second. ठीक है? So it's the reciprocal of the time period. ठीक है? कि 1 सेकंड में आपका जो पेंडुलम है वो कितनी ऑसिलेशन करता है. ठीक है? So it's basically the inverse of a time period. So if you want to find frequency, it's going to be 1/3.15, and it's going to be basically something in points. So आपके pendulum की frequency is basically 0.32 hertz, right? So in 1 second, it complete 0.32 seconds, right? So मतलब 8 सेकंड के अंदर it is going till here. ठीक है? This is half, so it's going till here. 8 सेकंड के अंदर. ठीक है? Since the time period is 3.15 seconds, it's huge. ठीक है? So it's these are not practical values. These are just uh, basically assumed values. ठीक है? Because my experiment actually क्या नहीं. So yeah, this is the meaning of frequency. Does that make sense for you guys? How do you do the experiment and measure time period using a pendulum? How do you find its frequency?
Yes, sir.
ठीक है? Good. Good. ठीक है. हाँ, now we had systematic errors over here, right? उससे पहले we had human reaction times that was basically introduced by us. We had parallax error that was also due to humans, right? By taking measurements. Now we have something called systematic errors. Can anyone tell me what is the difference between, let's say, an error introduced by us versus the error introduced by the apparatus? It's systematic errors. I just average. Give me a tukka. Tukka would work. I want Abdullah to answer this question. ठीक है? कौन बनेगा करोड़पति में? आपको स्वागत है अब्दुल्ला. So it's a question for billion of dollars. ठीक है? And the audience is watching you. I am watching you. Pakistan is watching you. ठीक है? We want the answer from Abdullah. Abdullah, what's the difference between systematic errors and errors introduced by humans, like human error, parallax error? It's literally written over here. You just skim it out and just tell me in your own words. Abdullah, I want to hear your voice. Abdullah can type out in the chat if you are shy. Abdullah is speaking up. Yes. Abdullah, I cannot hear you. Am I audible to you guys?
Yes.
ठीक है, I am audible. अच्छा, I guess Abdullah is trying to say, and I believe Abdullah is saying some correct things. Abdullah, I trust you. ठीक है? So systematic errors वो होते हैं जो basically introduce होते हैं from the instruments, right? So let's say you are taking a measurement, right? You're taking a measurement using this half meter rule, ठीक है? And you want to measure कि ये point P कितना ऊपर है टेबल से, right? And for this you're using half meter rule. But what are you observing over here? You're observing कि ये already start नहीं हो रहा zero से. It's not starting from zero. It has some x unknown length, which is up from the table, right? So this is, let's say your scale is giving you 5.9 centimeters, right? But this extra thing is basically adding up, right? So it's not the actual, right, the height which is given by the half meter rule to you at the moment, right? So this error which is introduced by the apparatus is called systematic. ठीक है? What you can do for this? So your actual answer is what? आपका जो रीडिंग आई है ना 5.9 सेंटीमीटर, वो कहाँ से आएगी? वो बेसिकली यहाँ से यहाँ तक, दैट इज फ्रॉम बेसिकली हेयर, फ्रॉम हेयर टिल हेयर, ठीक है. सो यू हैव दिस एक्स्ट्रा थिंग विच इज अननोन टू यू, दैट इज x centimeters. Your actual answer for the height of P above the table should be the following, right? Actual answer is 5.9 centimeter plus some x centimeter, which is unknown to you. Let's say this x is coming out to be, let's say, 0.6. So you have 5.9 plus 0.6. So your actual answer is basically 6.5 centimeters. So this x, this uncertainty which was introduced by your scale is called basically systematic. Okay. This type of zero error is known as systematic error over here. Why is it called zero error? Because the scale, the zeros of the scale is not aligned with the bench over here, right? So if this zero is over here, there is no zero error over here. Okay. We also see in Monday calipers and micrometers through gauge. These are basically two instruments used to measure the length. उसके अंदर भी होता है हमारे पास zero error, right? We will see what is that zero error there. So a half meter rule has a zero at the end of the rule, so that so can be used without introducing systematic error. Okay. So let's say this was a half, this was a meter rule. ठीक है. So instead of this, you can use a half meter rule. उसके अंदर जीरो हमारे पास अलाइन होता है फ्रॉम द स्टार्टिंग में, ठीक है. तो उसमें error आएगा नहीं. So when using a ruler determine to basically find out the height, the ruler must be held vertically, right? ऐसा ना हो कि आपकी, let's say this is the point which you want to measure, and you're putting the scale like this, right? So this is also going to give you a wrong reading. This is not flat over here. This is also called as systematic error. Right? So if the ruler is at an angle over here, so a systematic error is introduced. Again, the instrument is called basically giving you a cause of error over here. So these sort of errors should be known by you guys whenever you're answering present practical questions. Okay. So these can pop up in your ATP questions and also your paper 2 also. Okay. So theory के end में question आ जाता है बैठ के. So state the type of error which can be introduced in this experiment. ठीक है. So 90% वो parallax error होगा या फिर आपके पास वो systematic error होगा. उसके अलावा कुछ और नहीं होता. So मुझे कोई बताए कि what is vernier caliper? I guess you would have done this since you are getting grade 11. आप 10 के अंदर ही पढ़ के आ चुके होगे. Just give me a brief summary about vernier calipers and इसकी नीड क्यों पड़ती है, right? Why can't we use only just a half meter rule and a meter rule to do the reading? Why do we need vernier calipers? पहले जो पार्टिसिपेट करेगा, I'm gonna give you a bonus of +1 which would be added in your test one. ठीक है, तो आपका टेस्ट भी होगा after 2 chapters. ठीक है. So bonus of +1 जो भी बंदा होगा would get. ठीक है. So it will be added into test का. Yes. कौन बताएगा वर्नियर कैलिपर्स? Just brief introduction. Raise your hand if you want to participate. बोनस की बात आ गई है मेरी की दूसरी क्लास में, तो लड़ाई हो जाती है कि मैं बताऊंगा, मैं बताऊंगा. एनीवन गैस करो, तुक्का मार दो. इट वुड वर्क. इट डजंट नीड टू बी एग्जैक्टली करेक्ट.
Sir, I have never read this, but पिक्चर को देखते हुए मैं ये बता सकती हूँ कि स्केल पे तो एक स्पेसिफिक हम ले सकते हैं लेंथ, अगर उससे छोटी लेंथ लेने के लिए then we use vernier calipers.
कैन यू स्पीक लाउडली थोड़ा मतलब?
Can you hear me now?
यस आई कैन हियर नाउ.
तो सर मेरा ख्याल है कि स्केल पे तो हम एक स्पेसिफिक रीडिंग्स ले सकते हैं, तो अगर उससे छोटी रीडिंग्स लेनी होगी तो उसके लिए हम वर्नियर कैलिपर्स यूज करेंगे.
परफेक्ट.
जैसे कि 0.5 मिलीमीटर, इससे
ओके.
वर्नियर कैलिपर्स.
गुड. गुड. ठीक है. सो या तो चलें, मशाल गेट्स सम बोनस ऑफ 1. अच्छा, यू शुड रिमाइंड मी आफ्टर योर टेस्ट के साथ आप मुझे बोनस दिए थे. आई वुड आस्क द टीए टू ऐड द मार्क्स, राइट? और आपका टीए चेकिंग करेगा बैठ के. So I would ask TA to basically add on marks in your test. ठीक है. So yeah, that is correct. So let's say आपकी जो स्केल की जो रीडिंग होती है, हाफ मीटर रूल, ठीक है. So let's say this is 1 2 3 centimeters and then we have division over here 1 2 3 5 1 3 6. ठीक है. So इसके लीस्ट काउंट is basically 0.1 centimeter. So इसकी accuracy is also basically what 0.1 centimeter, right? उससे smaller reading he cannot give you. Let's as basically Mashal said कि let's say if you want to measure the let's say आपके पास एक ball है, it's a steel ball over here, and इसका diameter let's say is 0.25 millimeter, right? And if you want to take this reading, let's say if you want to take readings lesser than let's say 0.1 centimeter, you would have to use different instrument, right? So for that, for readings basically for the accuracy of if you want the accuracy of 0.1 millimeter, right? So you will use what? We use 1 year scale, right? 1 year calimeters. ठीक है, उसका लीज काउंट है 0.1 millimeter over here, so we use 1 year scale, right? अब इसके कुछ कंस्ट्रक्शन पार्ट्स हैं which you should be known to. So let me just insert empty slide to discuss इसके constructing parts which it contains. ठीक है, आपको नाम याद होना चाहिए because that can come in your exam. Okay, label and explain the parts of our calipers. If I can take the picture from here, just to basically annotate the next slide. Annotation. Yes. So it contains two type of jaws, right? So these are called internal jaws, right? These are called internal jaws, and these are called external jaws, right? External jaws. Okay. And this is called a ratchet over here. It's called a screw. Yes, this is used to basically fix your 1 year scale. This is your 1 year scale. You can make notes if you want to. This is called a 1 year scale, right? And this is called a mean scale. Right? You can move the 1 year scale if you can lose the switch, you can lose the ratchet. You can move the 1 year scale up and down depending upon let's say if you want to measure the size of this key, you can move, you can extend or close down the 1 year scale. Okay, main scale is fixed. So these are the construction parts for the 1 year calibers. So let's do some description for these parts. Okay, every part क्या क्या show कर रहा होता है बैठ के, ठीक है. So we have external jaws which are at the bottom, at the top of the instrument, ठीक है. So ये क्यों इस्तेमाल होते हैं? Let me just write it down over here. So external jaws are basically used for measuring internal diameter of hollow spheres. ठीक है. What do I mean by that? Let me just see. Let's say you have a tennis ball, right? You have a tennis ball, like let me just choose a green color. You have a tennis ball, right? आपने इसको 20 से ना काट दिया, let's say using the cutter or any knife, and you have sort of this semicircle, right? ये थोड़ा गंदा बन गया. You have sort of this semicircle over here. Let me choose the green color. ठीक है. Let's say if you want to measure the internal diameter, which is basically this, right? D1. So you can fit the hollow ball like this, ठीक है, and you can measure the diameter. इसका internal diameter कितना है, ठीक है. That is the purpose of external jaws. I hope it makes sense. ठीक है. Any questions in external jaws? Give me a thumbs up in your reactions if it is clear. Okay, हमजा को क्लियर है, मशाल को क्लियर है या नहीं?
So, does the external jaws move?
Can you repeat your comment? I lost you midway. Does the external jaws what?
Uh, does the external jaws move? That means how can we take the readings
Yeah,
from the
basically
main
आपके
scale
पास
or from the
yeah,
vertical scale?
you have a hollow ball, ठीक है. आपने उसको external jaws को ऐसे अंदर से फिट करना है from the inside of the ball. You can find कि internal diameter कितना है ball का, right? can just fix the instrument. Again, it can slide, like if you can move the vernier scale, वो extend होते रहेंगे. ठीक है, and you can measure के आपके let's say your ball का structure like a sphere. You can fix it like this in between, and you can measure internal diameter of the any object. Does that make sense?
Yes, sir. Thank you.
And the internal jaws, as you can see, it can measure the exterior, ठीक है, diameter of any instrument. It can measure, can fit it like this. ठीक है, you can see how it is, how it has been fitted. ठीक है, आपने देखा की कैसे fit हुई है. It just finds the length or let's say the external diameter of the ball. ठीक है. So if I just write it down over here, internal jaws, the purpose क्या होता है? So they are basically used for measuring external. Don't confuse with the names. ठीक है, internal का मतलब external, external मतलब internal. ठीक है, so external मतलब थोड़े it basically at the top, right? It's just the name convention. Or you can just name it top jaws, bottom jaws, whatever suits you. So conventionally, book wise, it's basically named like this. ठीक है, I hope it makes sense. Used for measuring external diameter of spheres or objects. ठीक है. Okay, so again place, let's say आपके पास tennis ball है, you know, cut, you don't want to cut the tennis ball, just want के overall tennis ball का diameter कितना है. You can directly place the tennis ball like this. ठीक है, directly place the tennis ball like this and just measure कि इसका diameter कितना है using this instrument, and it would be it would give the readings in millimeters. ठीक है, or if you can convert it to centimeters depending upon the scaling जो आपको दी हुई है. So it's just for finding external diameter of this, of the basically object, right? Any questions? I hope it is clear. ठीक है, so ये मैं रब कर रहा हूँ just to keep it clear.
सर आप डेफिनेशंस दिखा देंगे, मैं कॉपी कर लूँ.
हाँ sure. ठीक है, and then you have ratchet over here. Ratchet जो top पे screw होता है. ठीक है, it's just used for tightening the vernier scale in order to avoid movements while taking measurements, right? ताकि आपको scale आगे पीछे ना हो when you're taking the measurements. So what do? You have the scale. Let's say this is the object over here. इसको मैंने fix किया, मैंने vernier scale को tight किया, मैंने ऊपर से screw tight कर दिया, right? And now I can remove the object. Now I have the vernier scale fixed, which is not moving up, left and right. I have the main scale fixed. I can now just take the reading, ठीक है, कि reading क्या बन रही है, and just take and add it down, right? तो व्हाट आई वाज सेइंग कि लेट्स से आपने यहाँ तक इसका साइज लिया की का, एंड आपने स्क्रू को रेचेट को आपने टाइट कर दिया. नाउ कैन रिमूव द की एंड इट वोंट मूव आइदर लेफ्ट एंड राइट. द वन इज स्केल इज फिक्स. नाउ कैन टेक द रीडिंग्स. वी विल लर्न हाउ टू टेक रीडिंग्स इन अ व्हाइल. देन उसके अंदर नोट इट डाउन के आपकी रीडिंग पर्टिकुलर इसका लेंथ डायमीटर जो भी है इसका इतना होता है. आई होप इट मेक्स सेंस. ठीक है, तो फॉर कन्वेंशन लेट्स नेम इट लाइक दिस. लेट्स कीप इट सिंपल. लेट मी नेम इट इंटरनल ताकि आपको याद में मसला ना हो. ठीक है, यूज एनी कन्वेंशन. लेट मी जस्ट नेम इट इंटरनल जॉस ताकि आपको कंफ्यूज ना हो जाए. लेट मी नेम इट एक्सटर्नल जॉस, right? It's just a convention which whichever you want to use, but you should know okay what is it doing, right? यहाँ पे भी मैं इसको लेवल को चेंज कर देता हूँ ताकि you are not getting confused in the future. Internal jobs.
सर ये रेचेट की डेफिनेशन क्या लिखी हुई है?
Ratchet spelling is RATCHET. So what am I writing?
नो डेफिनेशन.
Definition ये है कि it's used for tightening the vernier scale in order to avoid movements while taking measurements. ठीक है, लेट्स से आपने डायमीटर अपने की को फिक्स कर दिया होगा here, then आपने ratchet स्क्रू को टाइट कर दिया, and then you can remove the key and the scales won't be moving left and right. It would be fixed. Now you can take the readings easily. On आप cannot keep the object together in the vernier scale. How would you be able to take the reading, right? So you can just fix the instrument. ठीक है, उसका size fix करें, ratchet को screw को tight करें मट के, then you can remove the object, you can take the readings easily, right? That is the purpose of bracket. Does that make sense?
Yes.
ठीक. And then you have the mean scale and the vernier scale. Mean scale and the vernier scale. ठीक है, so main scale is the scale
सर
which
एक
is
सेकंड, वो क्या कहते हैं, रैचेट की डेफिनेशन दिखाना, सिर्फ एक सेकंड।
Hamza, can you speak for loudly?
रैचेट की डेफिनेशन दिखाते हैं, एक सेकंड के लिए बस।
अच्छा देख लें, बता दें या फिर दिखा दें?
बस दिखाना था, अब आप कर लाएंगे।
ठीक है, so this is a scale which is fixed, it cannot move, right? And that is, I guess it, that is it, we know it is in millimeters. And vernier scale is the movable scale, ठीक है, which can slide over the mean scale, right? Which can slide over the mean scale. ठीक है, अब हो क्या रहा है, if you can see this, this is the main scale. ये आपकी जो internal rod है, that is fixed, it cannot move eternally. Vernier scale is the movable scale. You can move it left, you can move it right, depending upon कहाँ पे आपका जो instrument है, ball है और key है, कहाँ पे जाके वो fix हो रहा है, ठीक है? So this is the two types of scales over here, and they both are marked in millimeters. ठीक है, so let's now learn how to read the reading, right? हमें पता है कि वर्नियर स्केल के अंदर ये पार्ट्स होते हैं, ये पार्ट क्या करता है, ये पार्ट क्या करता है, हमें पता है, राइट? Now let's learn how to take measurements using a vernier scale. So let's go on to that slide. So now इसके लिए मैंने एक लिंक भी डाली हुई है बॉटम पे, which is pretty useful and it dictates everything in detail कि हम कैसे measurements लेते हैं. So you can just click this. मैं आपको जब slide भेजूंगा, you can just open this and read this document. This is pretty much in detail over here. So it also explains all the parts. ठीक है, so मैं आपको ये दिखाता हूँ. So why, if we have some good resources, I will be sharing those with you. ठीक है, so jaws for measuring inner dimensions, jaws for measuring external dimension, outer dimensions, vernier scale, main scale, ठीक है, screw clamp, we call it ratchet, एक ही बात है. And इसकी accuracy लोगों ने बताई है ये, ठीक है. अच्छा जी, so let me just now copy this part over here. ठीक है, ये थोड़ा important part है, ये देख लेते हैं ये क्या है. These are the definitions of the vernier scale and the main scale. राइट, अगर आपको ये क्लियर हो गई तो एवरीथिंग इज गुड. ठीक है, या मैंने लिखी ही नहीं लिखी, लेकिन इसको भी हो गई. ओके, सो व्हाट इज द मेन स्केल? अब आपकी जो लेट से रीडिंग जो आ रही है मेन स्केल की, इट विल गिव यू आंसर इन टू डेसिमल प्लेसेस, राइट? दैट विल बी 2.1 सेंटीमीटर, ठीक है. और लेट से इट इज 2 इज द फर्स्ट डेसिमल होल नंबर ओवर हियर एंड 0.1 इज द वन डेसिमल प्लेस, राइट? जब आपका वर्नियर स्केल होगा, दैट विल गिव यू द आंसर, the basically value for the second decimal base answer. Because your overall answer would be what? So let's say your answer of the reading would be 2.1 plus 0.03. So it would be basically 2.13 centimeter. So these two values would be arriving from what? From your mean scale reading. And this second decimal place would be coming from your vernier scale reading. Okay, VS, vernier scale reading, VSR, vernier scale reading. So what is VSR? It's basically vernier, अगर भूल ही जाए बाद में, vernier scale reading. अच्छा, अभी कैसे लेते हैं रीडिंग, वो लिख लेते हैं बैठ के. सो अब दिस इज द वर्नियर स्केल, ठीक है, दिस इज द वर्नियर स्केल जो विच कैन मूव, ठीक है, दिस इज द वर्नियर स्केल ओवर हियर. and this is your mean scale. ठीक है, अब जो आपकी ओवरऑल रीडिंग आती है फॉर द फाइनल आंसर, दैट इज एज विद द फॉलोइंग फॉर्मूला. So your reading for your final answer is your mean scale leading plus 1 year scale BSR, 1 year scale leading, right? So this is your overall formula for getting your answer. ठीक है, अब वो कैसे करते हैं, ये अब मैं लिखा हुआ है कि ऑब्टेन रीडिंग इज इक्वल्स टू मीन स्केल रीडिंग प्लस 1 year scale leading. ओके, सो अब हाउ डू वी मेजर इट आउट, तो ये देख लें बैठ के. लेट्स इमेजिन यू हैव दिस फॉलोइंग कंडीशन ओवर हियर. ठीक है, आपके पास ये रीडिंग की कंडीशन बनी है, आपने इंस्ट्रूमेंट फिक्स किया, आपने इसको टाइप कर दिया, देन दिस इज द बेसिकली setup which is appearing on your 1 year scale जो आप देख रहे हैं. This is the bottom one is called the 1 year scale and the top one is called the mean scale. अच्छा, how would you decide कि what is your mean scale leading? अब ये गौर से सुने. So your mean scale leading is the value. अच्छा, this is a zero of the 1 year scale, right? This is a zero of the 1 year scale, BS. So what is your mean scale reading? It is the reading which is before on your left of your zero of your 1 year scale, right? So what do you see on your left of your 1 year scale? It's 10 centimeter, right? तो यहाँ पे point नहीं आ रहा. If you see कि यहाँ ये 10 से 11 जा रहा है, right? So it's 10.1. ठीक है, it's यहाँ पे this is 10. This is 10.1. This is 10.2. This is 10.3. This is 10.5 and so on, right? So यहाँ पे you just directly see 10.0. So your main scale reading is currently what? 10.0 centimeter, right? Up, how do you choose? How do you choose your? So you want to have two reading. The main scale reading. The second one is 1 year scale reading, right? And how do you decide your 1 year scale reading? 1 year scale reading. अब you want to be vigilant over here, right? अब आपको देखना है कि कौन. अच्छा, you want to basically find out कि एक तो bottom पे ये है 1 year scale, top पे ये है main scale, right? So you want to find you want to find a point जहाँ पे इन दोनों की point की alignment हो, right? So where do you see कि you can see कि ये point basically same align हो रही है दोनों line, ठीक है? The point at which the 1 year scale line, but the 1 year scale leading and the main scale leading are getting aligned is your 1 year scale leading. ठीक है, ये दोनों लाइनें ऑलमोस्ट ओवरलैप कर रही हैं, राइट? ठीक है, समझ आया? मशाल हमजा. So this is basically what this is 0 till 10 over here. So this gives you second decimal place. So this will be basically 0.02. So your 1 year scale reading is 0.02 centimeter. Does that make sense? ठीक है, so your final reading क्या होगी आपके पास? आपकी final reading होगी, you will add both the measurements into the formula. So your obtained reading is going to be what? Your obtained reading is going to be 10.0, which was the mean scale reading. ठीक है, ये आपके उसके पास क्या आएगा? You will get the whole number plus 1 decimal place number. ठीक है, 10.0 है हमारे पास. Plus what is the 1 year scale reading? जो भी reading आएगी आपकी 0 से 10 तक, you divide it by 100 because it's basically 1/100th of a scale. Just imagine it's just the second decimal place. तो जो भी आपका आंसर आएगा going to be 0.0 something, right? So it's going to be 0.02 over here. So your answer is over here क्या है? 10.02 centimeter. This is your actual
सर
answer. The instrument reading. ये समझा?
सर मेन स्केल की जो रीडिंग है वो हम ऐसे निकालेंगे, 1 ईयर स्केल का जो जीरो उससे बिल्कुल लेफ्ट पे सबसे पहली लाइन है वो उसकी मेन स्केल की रीडिंग होगी.
यस यस, तो मेन स्केल की रीडिंग वही है जो आपके पास 0 ऑफ द 1 year scale, जो लेफ्ट पे आपकी जो लाइन आ रही होगी मेन स्केल की, दैट वुड बी आंसर. तो ऑन योर लेफ्ट व्हाट डू यू सी? डायरेक्टली सी 10 डायरेक्टली. ठीक है, क्योंकि 10.1 भी नहीं है, 10.2 भी नहीं है, तो इट्स 10.0 सेंटीमीटर. ठीक है,
अगर 10.1 होता लेफ्ट पे तो फिर वो
हाँ, तो it would be 10.1.
10.1.
Let's say if you are seeing this particular line on your left of the zero, this would be 10.1. ठीक है,
सही है,
so
समझ आ गया.
for 1 year scale you see कि कहाँ पे दोनों स्केल की लाइन अलाइन हो रही है. तो उस पे लेट से ये 2 पे हो रही है ना, तो यू विल जस्ट डिवाइड 2 by 100. तो जो आपका स्केल होता है 1 year scale, इट्स 100 of your mean scale. Okay? So just imagine it's the second decimal place of your answer. So it's 0.02. You will add these both answer over here to get the final reading. Does that make sense? Mashal and Hamza,
Yes.
give me a thumbs up if it makes sense.
Yes, sir.
Okay, ठीक है चलें good. अभी yes बोल दिया बहुत. Now we have the micrometer screw gauge. ठीक है. इसके भी we have some constructing parts over here, and इसकी we have the readings, right? So how much time will we have in the meeting? We have 3 minutes. We can discuss its constructing parts. इसके बाद when you will rejoin for the next 20 minutes, we can discuss the remaining topics, right? अब ये दिस इज इंपॉर्टेंट बिकॉज एमसीक्यूज में आपके आता है ना, आपको स्केल के मंडेस के बना के दे देंगे, बोलेंगे व्हाट इज रेटिंग व्हिच इज शोन इन द एग्जाम एंड द स्कीमेटिक, यू शुड बी एबल टू अंडरस्टैंड कैसे निकालते हैं. वी विल डू सम एमसीक्यूज तो उससे आपको आइडिया हो जाएगा चल द पासिंग. So now we have the second macrometer, the second basically instrument which is used for measuring pretty small readings. इसकी accuracy क्या होती है? इसकी accuracy, it is more accurate than the macrometer screw gauge. Oh sorry, vernier calipers. इसकी accuracy is 0.01 millimeter. Right? It's more accurate than the vernier scale. It can measure more small readings than the vernier scale. ठीक है? vernier calipers. So इसके we have some constructing parts. ठीक है? यहाँ पे इसका ratchet भी होता है, but किस छोटा सा we have a ratchet over here. इसके हम पूरे parts देख लेते हैं बैठ के, then we learn how to basically take measurements of micrometer screw gauge. So let me just snip this part. लिखा हुआ भी है yellow parts, so I'll explain it more in the next empty slide. ठीक है जी. So what do we have over here? We have the jaws over here. ठीक है. And इसको हम shaft बोल रहे हैं, इसको we call it basically main scale. ठीक है. ये वहाँ का main scale, मंडे कैलिपर की main scale होता है, यहाँ का main scale ये है. ठीक है. This is the circular scale. ठीक है, which can rotate. इन लोगों को टर्म बोला हुआ है. So I want to be specific about the terms because ताकि आपको कुछ clear हो. This is called a circular scale. ठीक है. And this is basically again a ratchet. Ratchet क्यों इस्तेमाल होता है? Just to fix the instrument. आगे scales आगे पीछे move ना करें. ठीक है. And when you basically rotate this ना, when you rotate the circular scale, और आपने इस्तेमाल किया left hand में, it gives you a ticking sound. Tick 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 tick. So when it moves, so it gives you ticking sound, right? So how would you basically know कि आपका instrument tight हो गया है? When you're also moving this ratchet. ठीक है. So you keep on tightening until you hear. ठीक है. So it does not tighten it further ताकि खराब ना हो इंस्ट्रूमेंट. It just basically gives you a tick tick sound. ठीक है. So it tells you कि बस अब बहुत टाइट हो चुका है, but it not tight further. ठीक है. So again इसके these are the jaws just to fix the instrument over here. ठीक है. So let's discuss every part in detail ताकि we can move on towards how to take measurements. ठीक है. So we have the jaws. ठीक है. What is the purpose of jaws?
ये जो
Yes. अच्छा एक मिनट.
ये सर्कुलर स्केल है, इसकी स्पेलिंग यही है या फिर? यस सर.
अच्छा हमजा, मुझे आप बताएं, कुछ पूछ रहे थे तो जोर से बोलिए, आवाज हल्की आ रही है.
मैं कह रहा था कि ये जो सर्कुलर स्केल की स्पेलिंग है, ये सही है या फिर गलत लिखी हुई है?
हाँ, स्पेलिंग देखो, फिजिक्स के अंदर ना स्पेलिंग की मिस्टेक चलती है. ठीक है. यहाँ पे स्पेलिंग मिस्टेक पर मार्क्स नहीं करते. यहाँ पे आपके मेथड्स, योर आंसर्स, योर कॉन्सेप्ट चेक होते हैं, राइट? सो आई माइट मेक मिस्टेक्स. थैंक यू फॉर दैट. So it's CIRCULAR. Okay, thank you. So don't be scared about spelling mistakes in your physics exam. Just be sure that you deliver the concept correctly. So if we have written secular in your exam and I'm checking it out, I'll give you the marks. ठीक है. But again, obviously not so blunders कि आप solar लेके आ जाए बैठिए. ठीक है. Circle in place of circular. ठीक है. Thank you for that. So what is the purpose of jaws? Jaws are basically used for gripping the object, right? For gripping the object. ठीक है. And then we have what? Then we have Allah wala kare aapka, not this. We have the main scale, right? So again, it's the scale which is fixed. It gives you a reading in millimeters. ठीक है. The fixed scale ठीक है, and it gives you the reading in millimeters. ठीक है, and then you have the circular scale, or इन लोगों ने इसको drum बोला हुआ है, क्या बोला हुआ है लोगों ने, drum बोला हुआ है, call it circular scale so that it makes sense. ठीक है, it can rotate right like this. It's called circular scale. It contains 50 divisions, right? Contains 50 divisions, and it can rotate around. It can rotate, right? Not move. Rotate like this. Rotate around the main scale. It rotates around the main scale. I want to be specific about my spelling mistakes. Someone is judging, right? अच्छा, okay. ठीक है. Then we have the ratchet over here. Ratchet क्या होता है भाई? Ratchet is again a simple tool used for tightening the object. ठीक है. Ratchet is used for tightening. Spelling mistake हो रही है यहाँ पे. For tightening the object in order to avoid movements while taking measurements. ठीक है, वही जो पर्पस था वर्नियर स्केल का, वही पर्पस यहाँ पर है, while taking measurements. ठीक है, so you can take a screenshot or I can wait for a minute. Any questions about the constructing parts of the instrument? Hamza and Mashal. I think Mashal सो रही क्लास में.
No, sir, not at all.
ठीक है, हमजा क्लियर है?
जी
समझ आपकी आवाज नहीं है.
जी
Not hearing you till now.
जी सर क्लियर है.
अच्छा, आवाज आ रही है. ठीक है, उसने बोला सर क्लियर है सर, आगे बढ़े. ओके, ठीक है, अंडरस्टैंडेबल. So these are the constructing parts of the micrometer screw gauge which you should be aware of. अब let's learn how to take measurements of a micrometer screw gauge. एक एग्जांपल है यहाँ पे. हाँ, ये एग्जांपल यहाँ पर एग्जांपल है. So इसको मैं थोड़ा आगे ले जाता हूँ ताकि it makes sense logically. We will discuss the first constructing parts and then how to take measurements. ठीक है, अब it's pretty simple to how to basically take measurements. Again यहाँ पे दो रीडिंग्स होंगी हमारे पास. Can anyone tell me कौन सी रीडिंग्स होंगी यहाँ पे? I told you that there are going to be two readings. So the final reading is going to be basically main scale reading, right? Main scale reading plus circular scale. ठीक है? So this is basically the reading of your reading formula of every instrument. तो आपको पहले इसकी रीडिंग निकालनी है from the main scale. ठीक है? Let me just label it again. It's called the main scale over here. And this is the vernier scale, right? Which we are referring to. Oh, sorry, the circular scale. उससे मटके के लिए मिक्स हो गया. It's CIR, right? Circular scale. ठीक है? जा. अच्छा जी. इसकी रीडिंग कैसे लेते हैं? How do we take the main scale reading? It's pretty simple, right? So आपके पास, if you see this instrument, आपके पास दिख रहा है कि 0 से 1 तक this only half a point, that is going to be 0.5 millimeter, right? Then you see 0 से 1, then 2. ठीक है? So the reading which is basically आपने close कर दिया circular scale, आपने ratchet को tight कर दिया बैठ के. Basically the line before the circular scale which you see is going to be your main scale reading, right? The line on your left, basically let me call it a datum line. ठीक है? So the line, the reading, basically the mark which you see on your left of the circular scale for this boundary, ठीक है, datum line, is going to be a main scale reading. Okay, so what is the main scale reading at the moment? यहाँ पे this is showing this particular slide over here, this point mark over here is 2.5 millimeter. ठीक है, this is your main scale reading over here. So आपके पास main scale reading MSR is going to be basically be what, 2.5 millimeter. ठीक है, which can be seen over here कि your main scale reading is 2.5 millimeter. इन लोगों ने सेंटीमीटर कर दिया बैठ के. So don't be घबराना नहीं है बैठ के कैसे हो गया सेंटीमीटर में. So if you want to go from millimeter to centimeter, you simply divide by 10, right? So अगर आपके पास 2.5 मिलीमीटर आ रहा है, so it's equivalent to basically 0.25 to 10, 0.25 centimeter. It's easy. And how do you basically check, how do you get the reading of the final scale? तो वो आपके पास होती है, ये सर्कुलर की रीडिंग आपके पास होती है, ये तो क्या होता है? So ये अच्छा, let me just call this as a data line. This is the boundary. So data line is basically the horizontal line over here. So this is the data line. ठीक है. And जो reading basically data line से align हो रही है ना, you can see कि this is 30, this is 31, this is 32, this is 33. ठीक है. So this line is aligning with the data line over here. So this is your circular scale reading. ठीक है. तो C ऐसा circular scale reading is going to be 33. ठीक है. So अब 33 what? ठीक है. आपके पास you would have to basically divide by 10 over here. ठीक है. Because ये scale down हुआ है. ठीक है. We have to basically divide by 100 division. So it has, ये दिखा दूंगा आपको. So you have to multiply with this particular factor over here, right? So 1/100th of 1 millimeter. ठीक है. तो उसकी स्केलिंग ऐसे हुई है कि every basically value of the circular scale is 1/100th of a millimeter. We're going to multiply this with 100. ठीक है. So just imagine जो भी इसकी रीडिंग आएगी आपकी is going to be in this form 0.33 millimeter. ठीक है. So this is basically the conversion method of getting circular scale reading into millimeters. ठीक है. ये सेंटीमीटर में, that is why लोगों ने extra zero ऐड किया हुआ यहाँ पे. ठीक है. समझ आ रहा है? So अगर आपके पास 0.33 मिलीमीटर है, so if you further divide by 10, you're going to get 0.033 centimeters. ठीक है. If we add these two things together, we'll get the same answer over here, 0.283. So अभी मैं आंसर निकाल रहा हूँ मिलीमीटर. So don't be confused about that. So let's get the final rating. ठीक है. So what is the final rating? So it's going to be 2.5 millimeter. जो आपके यहाँ पे आ चुकी. So it's going to be 2.5 plus 0.33. So it's going to be basically 2.83 millimeter. ठीक है. If you want to convert this into centimeter, just divide by 10, so you get the same answer, which is 0.283 centimeter. ठीक है. That's how you that's how you basically get the mean scale rating, the circular scale rating of the mathematical school course, and that's how you end up getting final scale rating. Any questions in this part?
सर ये जो डेटम लाइन इसके ये एग्जाम में हमें याद करनी है, एग्जाम के लिए ऐसी है बस?
ये आप पूछ रहे हैं कि आपने याद करना है कि डेटा लाइन बोलते हैं इसको, ये पूछना है?
जी.
हाँ, आप याद कर लें जस्ट फॉर योर रिमेम्बरेंस के हाउ डू यू, अगर यू कैन इफ यू कैन नेम इट समथिंग एल्स तो कोई बात नहीं. ऑफिशियली इट्स कॉल्ड द डेटम लाइन, दिस हॉरिजॉन्टल लाइन, एंड दिस बाउंड्री डेटम लाइन इज बेसिकली द लाइन व्हिच इज ऑन द मेन स्केल, राइट? तो बाउंड्री को मैं बोल रहा था बैठ के, सो इट वाज जस्ट सॉर्ट ऑफ जस्ट डिफाइनिंग द बाउंड्री बिटवीन द मेन स्केल एंड द वन स्केल. So I was just calling this datum line horizontal wise that this is the formal definition which you will see in your books. Yes, circle scale the reading is the reading which align with the basically with the data line. ठीक है. तो DATUM है, ये N नहीं है. ये मैंने स्पेलिंग थोड़ी राइटिंग भी खराब है. तो आई एम इंजीनियर बाय प्रोफेशन बट अ डॉक्टर बाय राइटिंग. डॉक्टर की राइटिंग अच्छी नहीं होती. सो या engineers की राइटिंग इज प्रीटी गुड usually, but not mine. I have a professor who taught me mathematical course. His writing was flawless, perfect. Okay. He did some joining italic writing, so he used to teach me mathematics, some calculus course. Okay. So I will show you inshallah in one of my classes the writing. तो ये पार्ट क्लियर है? गिव मी अ थम्स अप इफ इट इज क्लियर कि इसके कंपोनेंट क्या क्या होते हैं, हाउ डू वी टेक द रीडिंग एंड डेटा लाइन आपको याद करनी है. यस, गिव मी अ थम्स अप इफ इट इज क्लियर और नो तो यू कैन आस्क क्वेश्चंस. ठीक है. गुड है। अच्छा, ये लास्ट टॉपिक टू डिस्कस, उसके बाद वी विल एंड द क्लास बिकॉज वी आर हिटिंग द बाउंड्री ऑफ 1 hour। I have another class in 10 minutes. तो स्केलर एंड वेक्टर क्वांटिटीज, राइट, क्या होती हैं? इट्स वेरी सिंपल। कैन एनीवन टेल मी व्हाट इज अ स्केलर क्वांटिटी, व्हाट इज अ वेक्टर क्वांटिटी? जल्दी से, वी हैव 4 minutes quickly.
Sir,
Yes,
a
Misha.
scalar quantity can be known as a physical quantity which only has the magnitude but no directions.
Okay, good. And vector?
Like length, mass, time, and speed. And vector can be said as a physical quantity that has both the length, sorry,
Perfect.
the magnitude and the direction.
Good job. Okay, so ऐसे I want you everyone to participate, okay, without hesitating over here. So scalar quantity is a quantity, ठीक है? It is a quantity, a physical quantity which has a magnitude, ठीक है? A unit, a SI unit, ठीक है? And a direction, right? And a direction, ठीक है? So it can, sorry, not direction, no direction, sorry. ये eraser चाहिए थी मेरे को, and no direction, ठीक है? So these three things are basically available, and so it's called a scalar quantity, ठीक है? So इसके example देख लें. What is the example for this scalar quantity? As Mashal said, ये length, ठीक है? Let's say क्या ऐसे कि length of a pipe is 10 meters, right? So it has what? It has a magnitude. It has a magnitude. Yeah. It has a unit, but it has no direction specified. Okay, what angle at which it is there. Is it going toward north, east, west, south? Okay, it has no direction, so it is a scalar quantity. Okay, let's imagine if I say get time, right? So let's say time, the time the person took to, let's say, run 100 meters is, let's say, 146 seconds. Okay, again it has a magnitude. Okay, it has a unit, but it has no direction, right? You cannot specify direction in it. Time to direction cannot be specified. It is only if I go towards physics more depth, कि टाइम ट्रेवल की बात कर लो, यू कैन नॉट गो बैक इन टाइम, ठीक है? सो पॉसिबल नहीं है कि उसको स्पेसिफाइड टाइम की डायरेक्शन, राइट? तो दैट इज आल्सो अ स्केलर क्वांटिटी, ठीक है? देन वी हैव अ वेक्टर क्वांटिटी. तो उसके लिए आई वुड हैव टू ऐड अ स्लाइड ओवर हियर, ठीक है? देन वी हैव अ वेक्टर क्वांटिटी, वेक्टर, ठीक है? सो इसमें क्या होगा हमारे पास? इसके लिए वी हैव डेफिनेशन व्हिच इज एज फॉलोज. मैं कलर कॉम्बिनेशन जोड़ते हुए, सो अ क्वांटिटी which has, as you can guess, which has a magnitude, right? उसके बाद magnitude की कुछ value होगी, would have a unit and a direction, right? It would have a direction, ठीक है? So if it has these three things combined together, it can be called as a vector, ठीक है? तो इसका examples क्या होगा? इसका example मैं लिख देता हूँ बैठ के. So इसका example would be, let's say, velocity, right? कि velocity of the airplane was, let's say, 160 mile per hour eastwards, right? So इसके अंदर क्या है? इसके अंदर we have the magnitude, right? इसके अंदर we have the unit, ठीक है? And इसके अंदर we have the direction, right? So this quantity which has these three things will be called a vector, ठीक है? And let me give you one more example for vector quantity, and then we can end up
सर
with the
एग्जैक्ट
story.
मैग्नीट्यूड क्या होता है?
Yes,
मैग्नीट्यूड क्या होता है?
मैग्नीट्यूड होती है अमाउंट, कितनी है? 160 है, 10 है, 20 है, 20, that's the value. Magnitude is basically the value, right? Does that make sense?
मैग्नीट्यूड मतलब वो कोई वैल्यू?
हाँ, मैग्नीट्यूड मतलब अमाउंट कितनी है उसकी. 160 है, 20 है, 30 है, 40 है, 50 है, 1000 है, ठीक है? So on so forth. Make sense?
यस.
Let's discuss one more example of this. So let's say, imagine we are on Earth. Okay, this is Mother Earth over here. Okay, and let's say there is a satellite, right? Satellite charge. We have a satellite over here in orbit. Okay, let me name this, color this satellite and make its wings. Let's imagine we have a force of gravity, right? The centripetal force. Centripetal force, let's imagine this is the pull of Earth, right? This is the center of the Earth. This is the pull of Earth on the satellite. Okay, obviously, gravity Earth, okay? Earth will be pulling the satellite, right? That is why it is moving in its orbit. Let me name this as FC. Okay? FC क्या होती है? FC is basically the centripetal force. We will discuss this in the future. क्या होती है? Don't be confused. It's just a force which is keeping the satellite in a constant orbit, right? So you can see कि इस force का direction है it is towards the center of the earth, right? Let's say मैं कह दूं कि FC is 1500 Newton towards center of the earth, right? So it has again what three things over here. It has the magnitude, okay? It has the unit and it has the direction. कहाँ पे specify हुई. So this thing is called basically what? A vector. I hope it makes sense. So ये थोड़ा सा part बाकी है, which is let me just save the slides. छोटा सा part बाकी है, जल्दी से बताओ. Okay, it's making me wait. Let's wait for 2 seconds. Yeah, start. So vector addition वाला part बाकी है. इसके अंदर we will learn two methods to basically आपको अगर पता भी होगा. It's called head to tail method. ठीक है, head to tail loop. Okay, and the second one is called parallelogram loop. ठीक है, parallelogram. So why do we need this? Let's say आपके पास दो vectors दिए हुए हैं, ठीक है, like this. This is let's say vector 1 v1 and this is vector 2. And let's say if you want to find the resultant vector of this, ठीक है, वो this would be roughly around like this. Resultant vector and theta or angle O. So if you want to find what is resultant vector का direction and magnitude, what is the theta की value, ठीक है. So gonna be solving them using these two methods in the future. Inshallah, we discuss this example. I will give you can solve this example in the class also, or I can give you the homework assignment in the next class. And this is the checklist, the first chapter summary over here. And we have 5 minutes. We can discuss the story. Which story do I want to discuss? Okay. So do you know के अच्छा any question till now?
No.
Mashal, any questions? Mashal, are you here?
सर मेरा सिर्फ यही होगा कि एक दफा आप दोबारा रिवाइज करवा देंगे हेड टू टेल रूल और पैरेललोग्राम रूल तो बहुत अच्छा हो जाएगा.
हाँ, we will
क्वेश्चंस
basically हाँ ये
आसान
हम
हो जाएंगे
करेंगे.
सॉल्व.
ये हम करेंगे in the next class. मैं आपको बता रहा था ना, ये lose in the next class. ठीक है, अभी टाइम खत्म हो गया.
ओके सर.
We just have 5 minutes. So any questions till now? हमने discuss किया है.
नो सर.
Okay, so last just we have 4 minutes till I have another class, so we can discuss a story. Let's discuss on time travel. So can we go back in time? Is it possible?
It is possible in movies but not in real life as far as I know.
Okay, as far as you know. What about Hamza? Let me just draw some annotations over here. Let me share this slide. Hamza, is it possible to travel back in time?
पता नहीं, हो सकता है.
आप जोर से बोलें, आपकी आवाज बहुत हल्की आ रही है.
पता नहीं, शायद हो सकता है.
शायद हो सकता है. ओके, अच्छा एक पैराडॉक्स है. पैराडॉक्स क्या होती है मैं आपको बताता हूँ बैठ के. तो एक पैराडॉक्स है. आई वुड लाइक यू टू थिंक ऑन इट, ठीक है, एंड हैव सम डिस्कशन इन द नेक्स्ट क्लास. सो व्हाट इज अ पैराडॉक्स? इट्स अ नेवर एंडिंग थ्योरी, ठीक है. इट हैज नो सॉल्यूशंस, ठीक है. वो बस के अंदर प्रॉब्लम. सो ड्यू टू पैराडॉक्स टाइम ट्रैवल इज नॉट पॉसिबल. कैसे? इट्स कॉल्ड the grandfather paradox. Grandfather paradox. ठीक है, so what does it says? ठीक है, क्या बोलती है, क्या बोलती तू? So it says, yeah, let's say there is a person, let's say, let me name it Ali, ठीक है, and he hates his grandfather, right? Let's say he hates his grandfather. Let's say he used to punish him, used to beat him up, ठीक है, कुछ let's say कुछ दुश्मनी है. So वो क्या करता है? He invents a time machine, right? He invents a time machine, ठीक है, and what does he do? He goes back in time, when he goes back in time, let's say when his grandfather was young, right? Let's say he was young, उनकी शादी नहीं हुई, he was pretty young over here, ठीक है, and let's say अली की एज is 17 years. तो वो उस टाइम पे गया जब उसके grandfather, let's say grandfather was also 17 years, right? So what is the situation now? Ali bhai gaye, Ali bhai ne dekha grandfather ko, and in the next, this is sequence 1. In sequence 2, what does it do? Let's say he goes to with his grandfather, ठीक है, इनकी बिल्डिंग के ऊपर गए, grandfather was, let's say, enjoying the view, he was standing over here, let's call it grandfather, grandfather, I cannot write G है, बहुत सो गए बैठ के, and अली भाई ने क्या करा, अली भाई ने उनको पुश कर दिया, right? And few fall in the law of gravity, ठीक है, L, ठीक है, his father, grandfather basically died. Oh, ठीक है, like how do we draw a skull? Let me draw the skull. ठीक है, grandfather basically died, right? अब क्या मसला हो? What would be the issue over here? Can anyone tell me the issue? Okay, his grandfather is dead now at the age of 17. What would be the issue arriving now? Anyone? क्या होगा issue? टिक्का मारो.
अगर इसका पास्ट ही मर गया तो ये अभी प्रेजेंट में कैसे जिंदा होगा?
Yes, close. Okay, close. Okay, so what is the issue now? Okay, we have grandfather dead, right? We have grandfather dead. So if his grandfather is dead, okay, he won't marry, right? He won't, let's say, marry, okay. If he won't marry, the father,
How will the boy be born
yes.
if the
So
grandfather died?
his father won't be there, okay. If his father is not in the world, okay, he won't be there. Ali, let me name Ali. Ali shouldn't be there. Okay. So up this is a loop over here, right? That's why it's called a paradox. अब मैं इसको बनाता हूँ cycle. Okay. So it was basically Ali. Okay. And then Ali went and there is no grandfather. Okay, no grandfather over here. If there is no grandfather, there is no Ali's father. Then how is there Ali? Okay. How can Ali be there? So at that instant, Ali would disappear from the timeline history. Because at the moment his grandfather died, the timeline would change, right? This is the timeline. This is the infinite possibilities which can occur. Okay. After, let's say, as you say ना कि whatever you choose right now will deflect your future. So you have infinite possibilities right now which you can choose. And let's say आपने उस path को आपने तोड़ दिया, right? Let's say this was the path. ठीक है. Let's say this is the Ali's grandfather. Okay, he basically married, and let's say he had his father. Okay, Ali's father was born, and if there is Ali's father, then Ali was born. Okay, so this is the time. This is a specific path over here. Okay, ये specific path है. But let's say इसने ये path तोड़ दिया, so he won't be completing this path. Okay, he would basically choose another path. Okay, and this is the main issue over here. Okay, if you basically try to change any single event in the past, it will change the timeline very drastically. Let's say किसी ने जाके हिटलर को मार दिया पास्ट में, you won't be seeing the world which is right now which you are seeing. So that is why this is called grandfather paradox. It is pretty crazy, right? Time travel is possible theoretically, but I will also tell you in another story in the next class. Okay, it is possible, right? And we can do it due to single equation which we have. So this is just one paradox. So paradox ये होती है कि it is an infinite loop. It is unable to complete. It is still unsolvable over here. If you find a solution to this, let me know in the next class, and we would be happy to discuss this out. And if you have any questions, let me know. Okay, till if not, till then allow it. Like you will have two vectors, you would have to find the resultant and उसका angle. Okay, that is why you will vector addition. You will do some rearranging. There's some procedure. So let's start with that. ठीक है. जैसे क्वेश्चन हो मुझे फौरन आप you can raise your hand or you can speak up. ठीक है. Let me just reduce the size of this thing. Yeah. Okay. So insert home पे जाके you will insert an empty slide. Insert empty slide over here and let's start with the head to tail, right? We have the first thing which is head to tail. Head to tail. Is it recording? Is it recording?
Yes.
हाँ ठीक है फिर शुक्र मेरी सांस रुक गई थी ठीक है सही है so what is the head to tail rule imagine you have these two vectors ठीक है let me draw the vectors आपके पास ये दो vector है right let's keep it simple we have right angle triangle vectors okay it's 90 degree over here so we have v1 we have v2 over here and I give you a question okay Hamza let's say Hamza find the resultant of these two vectors right and this is part A and I also say कि find the angle theta it is making with the horizontal vector right and ये आपका 2 मार्क का है ये आपका 4 मार्क right okay so this is a question over here and you're employing head to tail rule ठीक है to solve this question अब let's start with this algorithm क्या algorithm क्या है इसके steps क्या है right वो start कर लेते हैं बैठ के let me do magenta purple ठीक है I want to have equality I support both the rights I support equality and man and woman ठीक है so let's choose pink color purple color over here this algorithm is as following algorithm first step is basically as follows okay the resultant vectors tail should touch the tail of one vector right and the second step is the resultant vector's head should touch I will explain what is the head what is the tail in a while don't be scared should touch the head of another vector ठीक है so अब what is the head of a vector what is the tail of a vector अब वो लिख लेते हैं let's imagine you have given this vector over here this thing is called the tail okay and this thing is called the head right तो ये इस अगर आपके पास एक वेक्टर बना हुआ है तो इसका जो हेड वाला पार्ट इज दिस एंड द टेल वाला पार्ट इज दैट आई होप इट मेक्स सेंस ठीक है अब आपके पास जो डायग्राम दी हुई थी लेट्स नाउ अप्लाई द एल्गोरिथम राइट तो आपके पास अभी ये दिया हुआ था ना कि यू हैव v1 ओवर हियर यू हैव v2 ओवर हियर तो इन यू कैन अरेंज द वेक्टर राइट आपको ना वेक्टर का डायरेक्शन चेंज नहीं करना और आपको उसकी ओरिएंटेशन चेंज नहीं करनी लेट्स से इट इज पॉइंटिंग अपवर्ड्स so you should not change the direction of the vector Okay, you cannot also rotate it. Let's say if it is pointing upward, it should be pointing upwards. You can move it left and right, up and down. ठीक? You can translate the vector. That is allowed. That is halal in physics. So what would happen if you rearrange them? ठीक है? You can अच्छा मैं क्या करूँगा, मैं इस वेक्टर को इधर ले आऊँगा. ठीक है? Let's see how. This is vector v1 and this is the vector v2. Right? The size and the direction is same. I just basically translated it from the right, left to the right. Okay? And your resultant vector will be the following. ठीक है, ये this will be your resultant vector. ठीक है, और does it obeys the head to tail rule? Yes it does. क्या कह रहा है result head to tail rule? कि इस resultant vector का tail should touch the tail of one vector. इसकी जो tail है वो एक vector की tail को touch कर रही है. Yes it is touching it. What is the second rule? कि resultant vector का head should touch the head of another vector, जो v2 आपका, and it is doing that कि इसका head दूसरे vector के head से मिल, right? That is the head to tail rule, and since it is forming a right angle triangle, आपको theta निकालना है, आपको resultant vector के magnitude निकालना है. So how can I find the resultant vector magnitude at the right angle triangle? If you had done some basic mathematics, you would have an idea about this. How can I, what property can I apply over here? Mathematics. जो बहुत
So what are you saying?
Pythagoras theorem, right? You were saying
Yes.
Pythagoras theorem? हमजा कुछ और बोल रहे थे.
I was saying, I was asking that what are you talking about?
मैं कह रहा हूँ कि I want to find resultant, इसका magnitude कैसे निकालूं मैं. मुझे v1 दिया हुआ है, v2 मुझे पता है. ठीक है, let's say ये 3 है. Let's say this is 3 meter per second. This is let's say 4 meter per second. मुझे ये दो वेक्टर्स का मैग्नीट्यूड पता है. आई वांट टू फाइंड आर. तो इन राइट एंगल ट्रायंगल, हाउ कैन आई फाइंड आर?
Pythagoras theorem, सही कह
Yes,
रहे थे आप.
yes, yes. Pythagoras theorem. When apply Pythagoras theorem, you all have studied that in your grade 8, 9, 10. ठीक है, सब पढ़ के आ चुके हैं, कुछ नया नहीं है. सो पाइथागोरस भाई ने क्या करा, पाइथागोरस भाई ने बोला इफ यू हैव अ ट्रायंगल जिसमें एक एंगल 90 डिग्री है, तो उसका लेट्स से यू हैव दिस ट्रायंगल ओवर हियर. ठीक है, दिस थिंग्स इज कॉल्ड हाइपोटेन्यूज, दिस इज कॉल्ड बेस, दिस इज थीटा, दिस इज कॉल्ड परपेंडिकुलर. सो दिस पाइथागोरस थ्योरम सेज कि h square is equals to base square plus perpendicular square. If you make hypotenuse subject, you can take square root on both sides. This will cancel out the square and the square root. So your h is basically under root base square plus perpendicular square, right? तो यहाँ पे आपके पास hypotenuse is r. Yes, your base is v1, your perpendicular is v2. So your resultant vector is basically r square equals to v1 square plus v2 square. ठीक है, if you take square root on both sides, this is going to be cancelling out the square and the square root of the r, and your therefore your r is simply what? It's v1 square plus v2 square. ठीक है, you can put the values later on. This is just generalized formula. या इससे निकालते हैं बेटा. ठीक है, so this is how you solve. You will have a formula for finding the resultant vector का magnitude. I hope it makes sense. So now let's think about the theta, right? How do we find theta? आपके पास अभी ये triangle मौजूद है. ठीक है, this is v1, this is v2, and this is resultant vector r, and this is the theta. ठीक है, you know how to find r now. You want to find theta. This is 90 degree. So what property can I apply over here to find theta? Anyone? If you recall from your mathematics class, okay, this is, let's say this is your right angle triangle, this is your hypotenuse, this is your opposite, this is your base. You have your basic trigonometric property, right? Okay, sin theta equals to opposite upon hypotenuse, cos theta equals to this base upon hypotenuse.
सर ये मुझे नहीं करवाया अभी.
आपने नहीं पढ़ा अभी तक?
नहीं.
अच्छा, कोई बात नहीं, तो पढ़ लें, कुछ इतना मुश्किल नहीं है. सो ये 3 आइडेंटिटी होती हैं बैठ के, जो आपने ना याद करेंगे इन योर ट्रिग्नोमेट्री चैप्टर. ठीक है, तो टेंजेंट थीटा होता है आपके पास ऑपोजिट अपॉन बेस, राइट? सो आपके पास अभी भूल जाए कि आपके पास ये है, आपके पास अभी आर लेट से नहीं है, आपके पास सिर्फ v1 और v2 नोन है. ये आपको पता है ऑलरेडी, आपको क्वेश्चन में लोगों ने दिया हुआ है. ठीक है, So let me just rub this R. Okay, you know how to find this R. I'm just saying that let's imagine if you have only V1 and V2, how would you find theta? Okay, with these two vectors. So कौन सा formula के हिसाब से you will basically you can find theta. You can use this formula because यहाँ पे अगर मैं लेबल करूँ, this is your hypotenuse, this is your hypotenuse, this is your base, and this is your opposite, right? So opposite base आपको given है. So which formula incorporates opposite and base? Tangent theta. ठीक है? So you can directly use tangent theta to find your angle. That is going to be V2 over V1. And if you want to, if you know कि अगर मैं theta निकालना है मेरे को, तो मैं tan को वहाँ भेज दूंगा, तो it will be tan inverse V2 over V1. ठीक है? That's how you can find angle. ठीक है? So let's do an example ताकि आपको idea हो जाए. So ये समझ आया मैथड पूरा सबको? So it's just a basic property. You will learn this in your mathematics course. Okay, in a while. So it's not, इसमें कोई derivation नहीं है, कुछ नहीं है, straightforward trigonometric identity है. So depending upon the things which are given, you can just use it.
सर ये मुझे नहीं समझ आया, ये टेन वगैरह जो है।
अच्छा, so ये यहाँ तक क्लियर है? ये कैसे आया? फर्स्ट स्टेप, टेंजेंट का फॉर्मूला क्या होता है?
नहीं।
टेंजेंट का फॉर्मूला होता है कि ये ऑपोजिट अपॉन बेस होता है ना. सो ऑपोजिट आपकी V2 है इन दिस ट्राइंगल, आपकी बेस क्या है V1. तो मैंने ऑपोजिट की जगह V2 पुट कर दिया एंड बेस की जगह V1 पुट कर दिया.
हमने टेन इस्तेमाल क्यों किया है?
हमने 10 इस्तेमाल इसलिए किया है, तो ये ट्रिग्नोमेट्री के अंदर एक आइडेंटिटी होती है. अगर आपके पास राइट एंगल ट्रायंगल होता है ना, जिसके अंदर इफ इन अ ट्रायंगल इफ एनी एंगल इज 90 डिग्री, सो इट्स अ राइट एंगल ट्रायंगल. सो इफ यू वांट टू फाइंड द अननोन एंगल, you can use these three identities to basically find your angle. ठीक है? एंगल निकालने के लिए हम ये आइडेंटिटी इस्तेमाल करते हैं. साइन कॉस हमारे लिए इस्तेमाल नहीं हो रही बिकॉज हमें ना हाइपोटेन्यूज पता नहीं है इन द स्टार्ट. हमें V1 अपोजिट पता है, हमें बेस पता है. So, कौन से फॉर्मूले में अपोजिट और बेस आ रहा है हमारे पास? दैट इज द थर्ड वन, दैट इज टेंजेंट, राइट? तो वी हैव थ्री आइडेंटिटीज ओवर हियर, A, B एंड C. सो यू कैन डायरेक्टली यूज टेंजेंट थीटा टू फाइंड द आंसर. हमने बस अपोजिट की जगह V2 डम कर दिया है. ठीक है, सब्स्टिट्यूट कर दिया बैठ के. बेस की जगह हमने V1 सब्स्टिट्यूट कर दिया बैठ के. एंड जब आप 10 को वहां भेजते हो, इट बिकम्स टेंजेंट इनवर्स. समझ आया?
थोड़ा थोड़ा सा समझ आया है।
अच्छा, ये स्टेप क्लियर है? द फर्स्ट स्टेप, दिस वन, ये कैसा है?
V2।
हाँ, ये मतलब पूरा जो आपका आइडेंटिटी बनी है.
जी जी, ये समझ आ गया।
ठीक है, ये समझ आ गई ना? तो बस आपको अगर ये समझ आ गया है, तो बस फिर आगे क्या है? अगर आपको थीटा, दिस इज थीटा, राइट? आई एम कॉलिंग दिस थीटा, दिस इज कॉल्ड, हम थीटा बोलते हैं. ठीक है, इसको मैं बनाया सब्जेक्ट. तो टेंजेंट यहाँ पे, अगर आप वहाँ, अगर यहाँ पे टेंजेंट को आप वहाँ रिप्लेस करते हैं, सो इट्स आइडेंटिटी कि इट बिकम्स टेंजेंट इनवर्स. सो इफ यू हैव अ कैलकुलेटर, तो इफ यू हैव कैलकुलेटर ओवर हियर, तो आपके पास दिखेगा टेंजेंट कहाँ पर है, राइट? यू कैन सी 10 sin 10 cos, ये उल्टा आ रहा होगा आपके पास. दिख रहा है आपको? जस्ट चेक योर कैलकुलेटर, यू हैव sin cos 10 इन योर कैलकुलेटर्स. कैन यू फाइंड दैट?
यस।
ठीक है, तो अगर आप शिफ्ट दबा के 10 दबाएं, यू विल फाइंड टेंजेंट इनवर्स. प्रेस शिफ्ट एंड प्रेस 10, देन you will find कि ये it is tangent inverse. So you just have to press that and put the fraction. That's it, you get the answer.
सही है।
समझ आ गया? मशाल क्लियर है?
सर, सर जरा एक एग्जांपल दीजिए जिसमें सिन या फिर कॉस भी इस्तेमाल हो सके।
नहीं, साइन और कॉस अभी इस्तेमाल इसमें नहीं होता है, मोस्टली यूज टेंजेंट. ठीक है,
ठीक है।
हाँ. मशाल क्लियर है? ओके,
Yes, sir.
गुड. So let's do an example. Let's do an example. Okay, let's do an example. And in example we can solve it out. ठीक है, let's say we have an example. ओके, सो आपके पास ट्रायंगल है जो अवेलेबल है, विच इज, लेट्स से आपको, आपने ट्रायंगल आपने सॉल्व कर लिया. लेट मी गिव यू अ क्वेश्चन. बोला चलो क्वेश्चन मिला था. ओके, तो आपके पास V1 गिवन है, लेट मी जस्ट नेम इट एज F1, आपको फोर्स 1 गिवन है, आपको फोर्स 2 गिवन है, ठीक है। एंड एक मिनट, sorry, so yeah, so you given F1, you given F2, and it's forming a right angle triangle, ताकि आप क्लियर हो जाए कि what are we talking about here, ठीक है। That's good to ask question, ठीक है, आगे क्या पूछूं इस क्वेश्चन। ये आपके पास F2 given है, and this is 3 newtons, this is 4 newtons, ठीक है। आपको रिजल्ट निकालना है इसका, ठीक है। You want to find, question is saying कि in the question का first part you want to find the resultant matter, you want to find theta, this is your question, right? वैसे एग्जाम्पल था आगे, मैं भूल गया, आगे क्वेश्चन अगर एग्जाम्पल है हमारे पास, a paradox and we have a question over here, चलें let's do this, ये सेम क्वेश्चन है वैसे, मैं 3 4 5 हाँ चलो इट्स द सेम क्वेश्चन, ठीक है, आई कैन कॉपी इट ओवर देयर, इसको हम यही ले आते हैं ना, लेट मी राइट इट ओवर हियर। So question is saying कि calculate the resultant of two forces, 3 Newton, F1 is of 3 newtons, F2 is of 4 newtons acting at right angles, ठीक है। आपको Fx दिया हुआ है, Fy दिया हुआ है, ठीक है, जो हमने डायग्राम आई बैठ के वही है, तो आपको Fx दिया हुआ है, राइट, आपको Fy दिया हुआ है, दिस इज दिस, एंड दिस इज 3 newtons एंड दिस इज 4 newtons, ठीक है, एंड दिस इज परपेंडिकुलर टू ईच अदर, यू वांट टू फाइंड रिजल्टेंट वेक्टर, ठीक है, जो मैंने यहाँ पे लिखा है, एंड यू वांट टू फाइंड थीटा, ओके। अब कैसे करेंगे, आपको स्टेप बाय स्टेप सब कुछ हमने वैसे एल्गोरिथम हमने डिजाइन कर चुके हैं, सो लेट्स फॉलो दैट एल्गोरिथम, ठीक है। तो दिस इज द सॉल्यूशन ओवर हियर, सो लेट्स डू द फर्स्ट पार्ट, यू वांट टू फाइंड रिजल्टेंट। सो सबसे पहले क्या करेंगे, हमको रीअरेंज द वेक्टर्स एंड फॉर्म द ट्रायंगल ऑफ फोर्सेस, ठीक है। तो आपने F1 को यहीं पे रखा और F2 को आप रीअरेंज करके यहाँ पे लिया है, एंड यू विल ड्रॉ रिजल्टेंट वेक्टर, your resultant vector is basically this is your resultant vector R, ठीक है, एंड दिस इज योर थीटा, एंड तो आपको F2 दिया हुआ है, दैट इज 4 न्यूटन, ये समझा, 3 न्यूटन।
सर ये जो आर है ये क्या हमेशा इसी डायरेक्शन में होता है?
हाँ, इट ओबेज द हुक्स लॉ, इट कैन बी, सॉरी हुक्स लॉ नहीं, हेड टू टेल रूल। अगर आपका लेट से ये F1 ऐसे होता तो ये आपका ऐसे बनता, इट डिपेंड्स अपॉन द
सही है।
डायरेक्शन ऑफ योर वेक्टर्स, ठीक है, इट कैन चेंज। अभी इन दिस
और
केस,
हम लोग को हर क्वेश्चन में जरूरी है ना कि एक ट्रायंगल बनाए।
हाँ आपको है बस हेड टू टेल रूल फॉलो करना है ना, आपको जो वेक्टर जो बनेगा आपका, इसकी टेल शुड टच द टेल ऑफ वन वेक्टर एंड हेड शुड टच द हेड ऑफ अनदर, ठीक है। So if it is following this property, then you have made the correct triangle of forces and the resultant vector direction is also correct, ठीक है। तो इसका head is pointing here, ठीक है। So let's solve for r, you know how to find r, हमने भी formula derive किया था using Pythagoras theorem, so we can apply that directly। So your r is going to be under root square of f1 square and plus f2 square, right। आपको f1 पता है, f1 is what, 3 newtons, f2 is 4 newtons, just put in the values and get your answer। Okay, so r is going to be equals to under root 3 का square plus 4 का square, and your r is going to be under root 3 का square is 9, 4 का square is 16, 9 plus 16 is 25, under root 25 क्या होता है हमारे पास, 5 newtons, right। So your r की जो वैल्यू अब क्या आ चुकी है, that is 5 newtons, ठीक है, आपका आंसर आ चुका है। अब आपने निकालना है एंगल, which is basically the resultant vector making with the horizontal vector, के horizontal vector से वो कितना एंगल इंक्लाइंड है, okay। So let's find the theta over here, part B में you want to find theta, so theta का फॉर्मूला आपके पास पता है, theta is equals to tan inverse, you can apply sin cosine, but मैं उसको आपको बताना नहीं चाह रहा, since आप लोगों ने पढ़ा हुआ नहीं है, you get confused। Let's say in the future inshallah when we do the past papers, I will guide you कि how to use sin and cosine, right। तो आप मुझे बता दीजिएगा कि जब आपने खत्म कर लिया ट्रिग्नोमेट्री चैप्टर इन मैथमेटिक्स क्लास, आई विल गाइड यू इन साइन एंड कोसाइन, ठीक है, when I will waste our time on just understanding what is sin cosine. Okay, tangent inverse क्या होगा, f2 upon f1 होगा. So because why f2 upon f1, because we have this triangle, right? आपके पास this is f1 over here,
सर
f2, this is your resultant vector r, this is theta. Yes Hamza, Hasan, Hamza, sorry.
सर हम लोग कौन सा एंगल ढूंढ रहे हैं वैसे?
हम ये एंगल ढूंढ रहे हैं ना, मैंने बनाया अभी, this one. एंगल मतलब रिजल्टेंट वेक्टर का, आप लेट्स से इफ योर रिजल्टेंट वेक्टर इज लाइक दिस, ठीक है, इज इट इज लाइंग ऑन द हॉरिजॉन्टल एक्स एक्सिस, आप इसको कितना एंगल से अप करेंगे, डेबिट करेंगे थीटा, कि इट इज एट दिस पर्टिकुलर इंस्टेंट राइट नाउ व्हिच इज यहाँ पे ये पहुंचा, तो ये थीटा आपको निकालना है. रिजल्टेंट वेक्टर आपको कितना एंगल बना रहा है फ्रॉम योर हॉरिजॉन्टल वेक्टर. डज दैट मेक सेंस?
यस सर.
ठीक है, सो जस्ट पुट इन द वैल्यूज. आपके पास f2 was 4 and f1 was 3, right? This was 3 newtons. This was 4 newtons. So 10 inverse आप करें इन योर कैलकुलेटर्स, 4/3 करें, क्या आंसर आ रहा है? इट शुड बी 53.13. लेट मी कंफर्म इट, मुझे आंसर से याद नहीं याद, तो करते करते मुझे आंसर याद हो गए हैं. इट्स 53.13 डिग्रीज. मेक श्योर कैलकुलेटर इज इन डिग्री मोड, ठीक है, नॉट इन रेडियन. So that is the answer, and you have solved it completely. Any question in how to solve this example? Is this example clear?
यस सर.
Mashal?
Yes.
ठीक.